Good morning, good afternoon, and good evening, everyone. This is David I, and with me here in Scotts Valley is Anders Olsen, off in the distance there.
Good morning.
Okay, and there he is. And welcome to this webinar, Mac Development for Windows Developers from a Single Codebase. We're going to be covering the Delphi and C++ languages, and with a specific section in the middle for C++ developers who might be coming from Visual C++ or some other language. And we'll be covering both languages with the demos throughout. This is the agenda for today. Starting here at 9 a.m. All these times are Pacific Daylight Time. So wherever you are, just do the date and time math or go to timeanddate.com. We'll start just with this quick hello and welcome and overview. Then I will talk a little about Rad Studio, and then Anders and I will introduce you to the capabilities of FireMonkey for doing Windows and Mac development. We'll have a 30-minute break, coffee break, so you can chat. We'll catch up on questions. You can take your own break, do some other things, but just leave your GoToWebinar client up and running. If you leave, it's hard sometimes to get your seat back, so please just leave it on. And then we'll go for another hour or so on what Visual Studio and Visual C++ developers gain from using FireMonkey, of course getting to the Macintosh. We'll also show you how Apple shows their beginning developers how to build a Macintosh Cocoa application using Xcode on the Mac, and also how to take a Visual C++ example and move it to a FireMonkey application and compile it for Windows and Mac. How to connect to web services that might be there, and also how to have FireMonkey run in a DLL or a dilib on Macintosh so that it can be called from other applications on other platforms, including VCL, C#, and so on. We'll take a lunchtime break at 12:30 to 1:30, and again, leave your GoToWebinar session going, or else it's hard to come back in. You'll lose your seat, and you'll have to re-register and come back in. So just leave it running through the whole time. And then in the afternoon, after the lunch break, we will go more deep into FireMonkey, into 3D, and also using the Delphi language into mobile development for iOS. And for you C++ developers, John Thomas, our Director of Product Management for Developer Tools, recently posted an article on EDN, which talks about our future directions for C++ Builder, our compiler, and for mobile and platform support. So you can check that out, and we'll bring that up somewhere along the way as well, probably in the C++ section, just to get an overview of where we're going with our C++ compiler and how we're going to get to not only C++ 2011, but also to iOS and Android in the future with both Delphi and C++. And AO is Anders Olsen, Michael's asking, and DI is David I. So just it was more to remind us who was doing which sections. But we'll both be chiming in and demoing back and forth and kibitzing on everything that's happening over the next 6 hours. So AO, Anders Olsen, DI, David I. And we're both here in the studio in Scotts Valley. So with that, let's start the formal part. Who's Embarcadero? Well, we're Embarcadero. We provide database professionals and application developers with tools to design, build, and run database systems and applications across multiple platforms and multiple databases. And we have lots of solutions for you, regardless of what your role is on your team. If you're an architect, maybe you're a data architect or you're a software architect, then we have software modeling and data modeling tools with our ER Studio and our UML built into our ID, and also a Software Architect as an external product that comes with ER Studio additions. You may be an application developer focusing on the code, focusing on testing, debugging, profiling, your application. Maybe you're a database developer and you need to work on store procedures and triggers and SQL statements and debug those. Then we have our Rapid SQL product and our DB Optimizer that does tuning and profiling of your database. Of course, for application developers, we have our command line tools and our IDEs as part of Delphi, C++, Builder, Embarcadero Prism, and Rad PHP, and Rad Studio, which includes all of those. If you're a database administrator, maybe you have to do all of these in your organization. Then we have tools for you to be able to manage, update, backup, do performance analysis, change management using DB Artisan. So you have all of the tools that are available for developers, DBAs, and architects across the whole line of products here at Embarcadero Technologies. Now, Rad Studio XE2 is the currently released set of all of our products. It includes, as I mentioned, Delphi, C++ Builder, Embarcadero Prism, and Rad PHP all in one set. And of course, you can buy the individual products separately as well. It's a complete suite for building Windows, Macintosh, mobile, and web-based applications. So there are the 4 products that are included in Rad Studio. We have several editions available for you as well. We have starter editions for Delphi and C++ Builder. That's for getting started. You can do Windows development using FireMonkey and VCL. With the starter editions for Windows. And then we have the professional editions of all 5 of the products. And professional lets you build desktop applications, local database applications that run on your machine. We have the enterprise edition, which allows you to connect to enterprise databases and do more enterprise architecture-based applications. We have the ultimate edition, which includes the enterprise edition plus our database tools, Rapid SQL, and DB Optimizer. And then we have our Architect Edition, which includes ER Studio for doing your data architecture, your data modeling, and then all of the multi-tier technologies that are available in our products as well. And then if you want everything that Embarcadero makes, we have our All Access Edition, which includes every tool that Embarcadero makes across the database and the application environment. You can see information about all those editions on our product pages, and there are also feature matrices for each of the products, and you can look at the feature matrix and look down the columns, Starter, Professional, Enterprise, Ultimate, Architect, to show you what's available in each of those editions. So if you need a specific technology, you can quickly glance down the columns of the feature matrices to see which edition is right for you that has the capabilities that you need for the types of applications you're developing, the databases you're connecting to, and the software architectures you're trying to use. Again, Rad Studio, all of our products, we use integrated development environment with visual design surface, component-based architectures, event-driven programming. So you can drag and drop components, connect the components together, write a little bit of code if you need to easily build the prototype of your user interface or your software architecture or your server side or your multi-tier application, and then build it, of course, to create the production application with little extra work. You know, when you're designing, when you're prototyping, you're actually building an application. For Delphi and C++ using native code, for Embarcadero Prism using managed code with the .NET runtime, and for PHP using the PHP runtime. Again, we use component-based development. The components have properties, methods, and events associated with them. And we have lots of different components, hundreds of components, and a whole ecosystem of technology partners that also provide components and tools that integrate with and add value to our development environment. So you can drag the components down. They're both user interface and non-visual components that are available. The visual components, everything that you'll see today in the visualization of buttons, edit, list boxes, tab notebooks, grids, all of these kinds of things. And also non-visual components for, again, doing multi-tier development, connecting to web services, connecting to databases, building web applications on the server side. All those components are available, and you can also create your own components. You can either extend or customize the existing components, or you can create components inside the IDE as well. And again, there's a whole ecosystem of free and commercial components that you can tap into inside of all of our technology partners and the people who are building components for you to have. New in Delphi XE2 included 64-bit Windows compiler. So you can take your 32-bit applications, rebuild them for 64-bit Windows, take advantage of larger memory address space. But with using FireMonkey, you can run applications on Windows, Macintosh, and iOS using the Delphi language. Of course, FireMonkey, which we're going to spend a lot of time today on, is about creating visually stunning applications both in high definition and 3D, and have those applications run on Windows and on Macintosh, all the target platforms, including iOS, using the Delphi language. For our customers that have been with us for a while that use the Windows-only VCL, or Visual Component Library, we have styles added to the VCL, so you can modernize the look and feel just by changing the styles of the visual components that are part of the VCL. You can connect to every kind of service. We also have support for Microsoft Azure and Amazon Cloud services, so you can connect to the storage elements, the message elements, and the table elements of those services, and you can also put your applications into those cloud application infrastructures as well. You can connect to web services wherever they are, and we have connectors for mobile devices to connect to servers that you might build, native code servers that you would build in Delphi and C++. Again, and a whole set of additional tools that are available from our partners, some of them integrated in, for example, a logging tool CodeSite from Raise Software, charting, 2D and 3D charting from Stima Software, T-Chart, AQTime, which is a profiler for your Delphi and C++ code, NSoftware's TCP/IP components, as well as the open source Project Indy TCP/IP and HTTP components. The InstallAware install system. IntraWeb is a server-side web server application framework for building applications that look and feel like desktop applications but are running in a browser connected to a server side. And of course, all of our products include the Interbase database as well. In C++ Builder, you can now target both Windows and Macintosh. We have support for FireMonkey. We've added support for doing static analysis of your C++ code to find problems that might be available that you might have put into your code, or stylistic conventions that you might want to clean up your code using. VCL styles also work with C++ applications. The same connection to cloud services, web services, and web applications and mobile devices is available as well, and all the tools are available. Rad PHP XE2 adds support for mobile application development. You can build your PHP server-side applications. Then you can also use reusable components to create the client side of your application. We've got components for jQuery Mobile to allow you to build mobile-optimized web pages that look native on the mobile devices for Android, iOS, and BlackBerry. We use the PhoneGap tool for taking the client-side part of your PHP application and packaging it up so that it can be sold on the Apple App Store or on Android stores or other places, or just side-loaded from a web server, for example, for Android and BlackBerry. We also wrap the Zend framework components, so if you're using the Zend framework as part of your backend infrastructure, you can get reusable components, just drag and drop in a visual design environment for email feeds, Google Docs, all the different things, spreadsheets, documents, calendars, and so on. For Google, all of that's available just with drag and drop reusable components using the Rad PHP component library, RPCL. And then we have Embarcadero Prism XE2, which is the Delphi language for .NET, for building applications for .NET, and also can be run using the Mono open source framework on Linux and on Macintosh as well. And also with Embarcadero Prism, you can build applications for Windows Phone 7 or Windows Phone Mobile or Windows mobile devices that are available now. And we're now shipping Embarcadero Prism XE 2.5, which includes early support for Windows 8, the Metro system. And there's a webinar coming up next week at the end of March, which will show you how to use Prism XE 2.5. Sorry, end of May, not end of March. That would be past. End of May. That'll show you how to build Windows 8 Metro applications with Embarcadero Prism XE 2.5. So check out that webinar as well. And all of our products include Embarcadero Interbase XE. It's the current version. Embarcadero Interbase is highly scalable, lightweight, full-featured, full ANSI SQL, SQL server. It has a multi-generational architecture. It has automatic crash recovery and archiving of transactions and changes that happen with the database. You just put it in and forget it as part of your infrastructure. It has a self-tuning engine. You don't need a database administrator to keep monitoring and managing it. There are lots of different versions. All of our developer tools come with the Developer Edition, which allows you to build prototype applications, do your development and testing, and then when you want to deploy your applications, just come back to us to decide how you want to deploy your applications. We have server editions for Windows, for Mac, for Linux, and Solaris. We also have Interbase in a DLL or a DLL. So if you want to deploy a DLL along with your application, that's a full SQL Server Interbase database. We have the To-Go edition for Windows and for Mac. And we have the desktop edition. So if you're building a small business application or a standalone application that needs a SQL database to run on the same machine as the application, we have the desktop edition for 32-bit and 64-bit Windows as well. And again, Interbase is included in all of our developer tools, but you can also download the free server trials and the free developer edition from our downloads page. So check out Interbase as well. Again, everything in Rad Studio, all the tools can connect to the databases that are out there, including Interbase, Firebird, Microsoft SQL Server, Informix, Oracle, Sybase, MySQL. We also in XE2 have an ODBC connector for our database components. So if you've got some other database like FileMaker or whatever that has an ODBC driver, then you can connect through the standard database components for Delphi, C++, and so on to connect to that backend database. And again, as I mentioned, you can connect to storage elements, to messages, tables, arbitrary NoSQL tables in Amazon's web services and Microsoft Azure infrastructure as well. And this is just a diagram that talks and shows a little more about all the connectivity capabilities that are available inside of the cloud services and the database services that are available in Rad Studio, XE2, and Delphi and C++ Builder, and PHP and Embarcadero Prism. First, you can build DataSnap servers, which are native code applications that run on Windows, built in Delphi and C++. You can implement methods, and then you can use HTTP, HTTPS. You can make REST calls, use JSON packets to pass parameters, pass objects, make calls to methods, return the results. All of that putting your applications or your business logic inside of a nice native code application server with full lifetime support and server control and capabilities. That's available for Delphi and C++, and you can build client applications in JavaScript. You can build client applications in Delphi, C++, PHP, and Embarcadero Prism. You can build client applications that can talk to DataSnap servers using Objective-C on iOS, Java on BlackBerry and Android, Prism or C# on Windows Phone, and you can use Delphi and C++ clients on Macintosh as well. Again, you can connect to all the data and all the cloud services that you need, or you might have some web services built. You'll see in one of the sessions today that you can connect to ASP.NET web services built in using a .NET language, for example. We'll see how to connect a FireMonkey application to an in-place infrastructure you might have. There's a couple questions that came in while I was doing the overview. One was, Doug said his VCL styles doubles, increases the size of his exe file. You can have the VCL styles linked into your executable, or, Doug, you can have the VCL styles external to your executable. You can just put the VCL style files, and you can load them from a file in your code at runtime. You do not have to link the styles into your executable. That's a choice under project options for VCL styles. You can check to have all the VCL styles available, and they'll be linked in, or you can just load them in code as well. And Rick asked, what about SQLite support? There is a SQLite driver for Delphi and C++ Builder from DevArt, DEVART.com. They have a DB Express driver for SQLite. Anders Olsen has blog posts that shows how you can access SQLite, which is included inside of iOS. And he's got blog posts and demos that you can download showing how to use your Delphi FireMonkey application on iOS to talk to the SQLite database that runs inside of the iPhone, the iPad, and the iPod Touch. Okay, and again, as I mentioned, there are editions for everybody. Here's this picture I found a long time ago of a kid who's just getting started, or maybe you're starting a new career, or maybe you know some other language. In my weekly lessons, they're getting started with Windows and Mac development that happen every Thursday. I've got a couple people that are coming from JavaScript as the language that they know, or they know Visual Basic for applications. They've done a lot of Excel and Windows, Microsoft Word programming, and so they're just getting started, and you can use FireMonkey for Windows in the starter editions. The professional edition includes FireMonkey for Windows and Macintosh for building desktop applications, local database applications. The enterprise edition, which gets you connected to all the databases. Ultimate edition, which includes the database tools, as I mentioned before, and the Architect edition, which gets you the data modeling and the software modeling, gets you the multi-tier, all of that capability. And again, look down the feature matrices. The links are on the right-hand side of each of our product pages, and you'll see the capabilities that are inside of each of the editions. And again, All Access is the Ultimate edition. It has everything that Embarcadero provides: databases, database tools, developer tools. It's like 17 or 18 tools all together, and you can have the All Access edition as well. Here's my Macintosh desktop environment. When I install Rad Studio XE2 or Delphi XE2 or CBuilder XE2, there's of course the IDE that runs on Windows. The other part is a configuration or a remote debugger. We call it the Platform Assistant or PA server that we install on the Macintosh, or that you install on a Windows target, so that you can use our ID on Windows, deploy and debug your applications on a target Windows. Maybe it's a Windows Server or some other remote Windows desktop application for someone, and also on the Macintosh. So in order to connect from the ID to the Macintosh to be able to do the deployment, application execution, and also debugging, I need to install and run this Platform Assistant. And so I'll start it up. I've already installed it, and it sits on my Macintosh side. And if I want to have a password that connects the IDE to the Macintosh so that nobody else can get in there on the same port and do something, I can key in a remote profile password. If I don't care, I'll just hit Enter. The next thing that'll happen when you first boot up your Macintosh, first start the Platform Assistant server, is that it will ask the Macintosh to be able to connect through a Developer Tools API that's available on the Mac. So it puts up this box: Developer Tools Access is trying to take control by this PA server, so I just need to log into my administrator account. And now the Platform Assistant is started, and it's running on a port. There's command line options. There are also in-memory options as well for the Platform Assistant server. But if you want to run on a different port, there's a command line option. You can create a configuration file. I'm running on port 64211, which is the default. But if you're in a firewall architecture in your infrastructure and you have to open up a port or go through a port, then you can specify whatever port that you want. So now that the PA server is running on my Macintosh, I can switch back to my Windows IDE. Now here's my Rad Studio IDE. I've got both Delphi and C++ installed. I've also got Visual Studio installed as well, because we're going to use that throughout the C++ and Windows and VC++ part of the demonstration. So I've got Visual Studio 2010 Professional installed as well. I also use the Visual Studio ID to do Embarcadero Prism work. Embarcadero Prism installs into the Visual Studio shell, which we ship, or if you've got Visual Studio Professional, it installs inside of the Professional, or if you've got an Express Edition, Embarcadero Prism installs inside of the Express Editions as well. Okay? All right. So inside the IDE, I can control and do whatever kind of application development. I can create a new FireMonkey C++ application. I can open existing ones. I can create new FireMonkey Delphi applications. If I want to see all the commands, I can say File, Other, and here are all the different C++ projects. I can create a DLL, a VCL, a service application, a static library, a console application, an active library. I can build just source files and header files, DataSnap servers. I can create a web server application, create web services, a SOAP server. I can do the same kinds of things for Delphi. I could create a UML project, either 1.5 or 2.0 design project. I can create an intraweb, server-side application. I can use AQTime to do profiling, create a profiling project. We also have unit testing built in for DUnit for Delphi, a CUnit for C++, and NUnit for .NET development. And then if you're doing things with the web, I've got a XML, CSS style sheet. We've got wizards to start those, and we have different views that are available for different kinds of editors. This is my welcome page in the ID. It has my most recent projects and also my favorites. So I've got favorite projects, and there's a favorites manager. There's also these menus inside the welcome page to show your projects, get news from Embarcadero, get to other resources of information, also get to our documentation. FireMonkey is an application development platform for Windows, Mac, and iOS development. iOS currently for Delphi, Windows and Mac for Delphi and C++ languages. We call it an application development platform because it's more than just a user interface framework. There's a T application object. It has encapsulation of platform-specific capabilities on Windows and Macintosh and iOS, so that you write one set of source code in C++, you write one set of source code in Delphi, and you can compile and build your application for Windows, Mac, and iOS using that same source code. So FireMonkey not only encapsulates the user parts, it encapsulates the underlying operating systems. And there's runtime libraries for C++ and for Delphi that also give you access to the underlying systems. One of the great things about FireMonkey, besides that you can build everything with one set of source code, is that you also still have access to the underlying operating system, to the underlying hardware. So you don't have to worry that you're being blocked by something that you have to go through FireMonkey to get to. You can go deep underneath. FireMonkey also includes a T-canvas object, and you can do low-level manipulations of the screen using the canvas object on Windows, and there's a T-canvas that gives you brushes and other things, and pens and so on, for Macintosh as well. Of course, the runtime libraries implement the right things on each platform. And the way FireMonkey works as an architecture is that it works with the underlying high-definition and 3D interfaces and the GPUs that are available in your hardware. So to do HD or high-definition development of applications, we use Direct2D on Microsoft. We use the core graphics libraries of Macintosh and the core graphics libraries of iOS. To do 3D programming, on Windows, we use Direct3D, and on Macintosh and iOS, we use OpenGL and OpenGL-ES. Again, the little note here is about for iOS and OpenGL-ES, it's Delphi only currently. So you have full access to the CPU, of course. You have full access to the GPU. And so a lot of FireMonkey, and Anders will cover this more, especially in the 3D section in Advanced FireMonkey, how you can get high-speed performance by using 3D, where the GPU is doing a lot of the work, is doing a lot of the manipulation. FireMonkey also comes with image and effects operations, and those use the Pixel Shader API that's available to the GPU. So if you want to do effects, we'll talk about those in a moment, show those in action. The GPU is doing all of the work. Here's the slide that talks about the fact that the CPU is being offloaded by the GPU so that CPU can spend its time doing your application logic, doing the business logic that's available, what your application needs, or waiting for mouse clicks or human interactions in the application. And the GPU is being leveraged by the FireMonkey application platform to do high-speed rendering of your applications. The other thing to think about in FireMonkey is all vector-drawn. So it's vector-based, it's scalable vector graphics, so it looks great on any resolution, on any device that's got a GPU. And people usually ask us, well, do I have to have a GPU? And well, over the last 7 to 10 years, most computers that ship, especially in the more recent years, have a GPU of some kind. And the way we usually tell people to know if your computer has a GPU is if there's a DirectX 9 driver for Windows, if it's a Windows machine, then you've got a GPU. So if there's a DirectX 9 for your graphics card, for your computer, maybe you've got the integrated Intel high-definition graphics chip on the motherboard, it's got a GPU built in it that's Pixel Shader 2.0 or greater. And so FireMonkey will work great with your GPU. If you don't have a GPU, if you've got some old computer that's just got a CPU and some kind of graphics card, FireMonkey will drop down to GDI Plus if you only use high-definition graphics components, you don't use any image effects or animations or 3D. So if you have to constrain yourself because of some old computer that you need to deploy a certain application, but you want to take advantage of the FireMonkey application platform, then it will drop down to GDI Plus if that's available. But again, most computers in the last 7 years, all the Macintoshes, all the iOS devices from Apple have a GPU. So FireMonkey will just take advantage of it. You don't have to do anything special in your code. Just use the components, use the capabilities of FireMonkey, one set of code written in C++ or Delphi, and you can get your full graphics acceleration running in both high definition and 3D applications. And FireMonkey comes with more than 50 effects and available, and it also has support for animation. And by animation, and maybe Anders will show something here in a few minutes, we've got lots of different demos that show animation in action. So effects are things like doing dissolves, doing magnify, sometimes called pinch and punch, sepia, monochrome, blurring effects, all these different kinds of effects. And inside the IDE, there are components for all the effects. And you can apply multiple effects and different effects, a reflection effect, for example, on all the user interface components of FireMonkey. And it's all done through the Pixel Shader API inside of the GPU, so it has no performance hit on the CPU. I should take that back. I think monochrome, it might actually do that in software versus the Pixel Shader, but sepia, color enhance, again, there's lots of effects, and there's even an article, if you search for FireMonkey effects, I think it was out of the Australia Delphi user group. There's a great article about how to build your own custom GPU effects as well that will work with FireMonkey and using the Pixel Shader language. And you can look in the source code if you have a paid version of our products that include FireMonkey, which is Rad Studio, Delphi, and C++. We give you the source code to the implementations of the effects and all the components in FireMonkey, so you can actually see the Pixel Shader code or the Pixel Shader bytecode, pre-compiled code, inside the source code to see what's going on for all these different effects. For example, Gaussian blur and so on, and magnify. Animation, in the case of FireMonkey, is the movement or the change of property values over time. It's not animation like you would see in Pixar with moving arms and fur that waves and moves in the wind or glints with the sun. The animations here are to animate properties and you can specify the animations for different properties based on types of properties. And there's bitmap animation, there's a single precision floating point animation, there's several different animations. And when we show you the IDE in the Object Inspector for a FireMonkey application, you'll see a little film strip in the Object Inspector. Let me just switch to that to show you real quick. Let's say File, New, C++, Builder HD Application. And so if I put a button, for example, down on the form, you'll see in the Object Inspector, for example, the position, this position property. I know this is System Font 9, so I apologize if it's very small. But if you see in the Object Inspector a little film strip to the left of the property editor, for example, for the position of the button, you can click on this and you can create a float animation which is going to modify the X or Y position, for example, in the case of a button, over time. So we could say create a new float application. We could do it by doing that, or we could go under animations down in the FireMonkey component library. Here's all the different change color over time, change the gradient over time, change a single position, a floating point value over time, animate a rectangle, a bitmap, a list of bitmaps, path animation, which moves a FireMonkey component around some prearranged XY path. So we could drop those components down, or we can use the Object Inspector. And again, this just says, let's change the duration and a starting and ending value, for example. So if I wanted to move this button's X property and move the button around over time, we could set a value and a stop value. And we can also set a trigger. So all animations have triggers. So you can either enable them and have them run, or you can trigger, for example, if the mouse is over, set a trigger, and a delay and the duration, do it over a period of time, like 1.5 seconds, for example. Oh, I didn't enable it? Okay, well, that's why there's two of us here. Let's enable it, and let's run it. And so there's the animation that is trying to move away from me when I hover over it. And it also did the animation when it was enabled as well. Let's see if I go and disable it and run it. Then it's just going to do it when I hover over it. So it's trying to get away from me as well. Okay. So again, animations and effects. So let's, Andrew, do you want me to load the effects example? Let's see, I can do that. Okay, so let's forget about this one. Since we're here, let's go to, let's see, where, here's one. Here's an example. So let's just, this is a demo example that ships in Rad Studio and Delphi and C++. It shows some of the different effects. For example, I can do a blur, so a box blur, a directional blur, a Gaussian blur, and you can really choose the either not blurring amount by using the slider or blurring it like crazy. So again, all of this is a radial blur. You can pick where the point is in this demo and then how much blur around it. Distortion, a distorted effect, geometry, style, I love these. Emboss, one of my favorite, sketch, pencil, script. So if you want to do these kinds of things on images, do image effects, there's sepia, and you can specify what the amount of sepia is, for example. So this is just an example of all the different effects. Here's transitions, transition effects, blood. Yeah, I never quite figured out. But okay. Blinds. So things you would see in Adobe Photoshop, you'd see in Adobe Premiere and other video editing tools, these kinds of doors for blinds, swirls, you pick the points and so on. So underneath all this is doing, this demo is changing the properties of these effects, and you can do the same thing in your own applications by saying File, New. Let's do a Delphi application, for example, and we could go in and put an image component, if I can type image down. So we can put a T-image component, and we can go and set its bitmap. So I'm using the object inspector in this case, and we can go and load a bitmap. Let's see what we've got here. Let's go to pictures, public pictures. There's these beautiful koala bears, for example, and we can fit it. And then we go under effects in the IDE. Did I cancel it? Oh, that was bad of me. Come on, I want that beautiful koala bear. Did I hit cancel? Oh, I said fit. Oh, I hit the cancel button there. Sorry. So here we've got an image. We can now put a blur effect on it, and just drag the blur effect for the image, and we can enable it and trigger when we mouse over it again. And it's blurred, but let's disable it until we're over it. And so if we put the mouse over it, it'll blur, right? It hurts my eyes because I have bad eyesight. When I see blurred, my eyes are trying to clear it up. So you might use blur, for example, to hide an image or set it off in the distance. You might use X, Y, and Z if you're using 3D to send an image off in the distance and bring it back. You might want to do a blur just around part of it to highlight a part of an image that you're getting from a database, for example. So images and effects, and this is a chart of the FireMonkey hierarchy. It starts with T object, and then there's and that's where the persistence, because all the FireMonkey objects can be persisted out to a stream. They can be stored in memory. You can access the registry for your non-streamable classes. You can create components, visual and non-visual components. Non-visual like T data source, T client data set, the database components, web services, and so on. And the base class for FireMonkey components from that is TFMX object, which allows you to style your FireMonkey objects, and we'll talk about and demo those. Controls like buttons, panels, list boxes, edit boxes, and so on. There's also shapes, both 2D and 3D shapes. Lines, circles, ellipses, rectangles, and so on. And this slide was from Ray Konopka's Code Rage 6 talk on building FireMonkey components. We have high definition or 2D forms with full support for all the user interface components for styles inside of FireMonkey, and you have full support for 3D as well. So 3D forms, we'll see that in the advanced section. Anders will be showing you lots of cool 3D scientific and engineering type applications. And this is just a UML diagram. Pavel, one of our SCs in software consultants in Europe, used the UML surface inside of Rad Studio XE2 to create a list of the 3D objects that are available in FireMonkey. So again, it inherits from TFMX object and then goes through a control 3D instead of a T control. And that gets you to your 3D shapes, your 3D grid. We have a custom mesh. You'll see that in action using T-Mesh, where you can create your own surfaces and your own visualizations. Cubes, cones, spheres, rectangles, cylinders, a plane. And also we have a model 3D component as well. This thing called T-Dummy is sort of a proxy container that you're going to put things inside of, and it helps you manipulate parts. You can also put a 3D object into a high-definition form by using an object called Viewport 3D. So if you want to build if you have an HD application or a 2D application and you want to have a part of it do some 3D operations like a graph or some kind of model visualization coming from Maya or some other 3D tool, then you can create a viewport and still have the ease of use of the high-definition XY coordinate system of a application layout, but have a 3D part to do operations, a 3D pie chart or a cube or whatever it might be. That's available as well through the Viewport 3D, so you can put 3D inside of a 2D. You also have the ability to create a FireMonkey form, either 2D or 2D form, and call it from other applications. We'll see that in action in a little bit. You can put a FireMonkey form in a DLL and then connect it to a VCL application, connect it to a C# application, to an Embarcadero Prism application. And so you have all the flexibility of building the different kinds of application pieces and parts available using FireMonkey. And then we can connect to databases with all the visual components inside of FireMonkey, and you can do all sorts of great 3D and 2D visualizations as well. So with that, Anders, let's show. I showed a couple of the examples, just FireMonkey examples, like the image example. Maybe another one to show real quick is the controls demo.
Yeah, go ahead.
Because that shows.
If you want to show the Brazil one before you switch over to me as well, you can do that.
All right. So let me show controls demo first. Controls demo is, we have both C++ and Delphi versions of the controls demo, and it's a showcase for the many of the visual controls that are available in FireMonkey. We've got edit boxes, we've got radio buttons, check boxes, all the usual things, a list box, a track bar and a scroll bars, all these things that are available. This is in the design surface now. We've got expanders, angle buttons, track bars, a number box where as you click in it or move through it, mouse over it, it'll bump up and down. Calendars, different kinds of calendars, pull downs, calendar views. You can have all the visual components have a transparency, or the property is called opacity, and so you can set the how much of an object appears. So, for example, you might use opacity to hide an object, and then start having its opacity be animated from 0 to 100% to have it appear out of nowhere as part of calling attention to the user interface of your application, for example. You can also rotate. All the HD components can be rotated. They have not only a position property, but they also have a rotation angle. So this is an angle from, 0 to 359 degrees available, and you can set what the rotation center of any object is as well. So every object in FireMonkey has an opacity. It's set to 100% or visual, but you can set it to 0. And this part of this demo we'll see in a moment. One of the great things about FireMonkey, and we can see this in the structure view as well for the application, is that FireMonkey components can contain other FireMonkey components. So you can composite your components together. In the VCL world or in the Windows world, forms, dialog boxes, something that had a Windows handle could contain other controls. In FireMonkey, every component can contain other components. You can composite components together. And so, for example, here's a list box that has just regular text in an item. Here's a list box item that has a label and an image inside of it. Here's one that's got a label and a path animation. Here's another one, a list box item that's got an edit box and a label and a button inside of it. And so you can composite just by creating a list box component, dragging it onto user interface, and then dragging components inside of each of the list box items, as many as that you want. So you can build up composite components. You don't have to create a new component. You can just take an existing component and add things to it. So, for example, you could composite a label, an edit box, and a button together. And then when you drag the edit box or the button, whichever is the parent around, the other components that are associated with it will drag along with it as well. Again, scroll boxes. This has got expanders inside of a scroll box. We've got a T memo. And there's all sorts of other components like the arrow components, combo edit, spin box, loss of checked list box items, checked tree view items, and so on. So this in action, we'll just compile and run it. So here's the standard component. It's just text. We've got the little animator that you see all the time, different kinds of scroll bars, track bars, progress bars. Here's the list, traditional list box item, just choose it. Here's the list boxes, speed buttons, call-out panels, additional components. That's an expander, a collapser. Here's these angle buttons that you can spin. A track bar. This is a number bar. So as you drag inside of it, notice it's got this glow effect. That's one of the other effects that's available. So this is triggering a glow when the cursor is inside of it, where I can do things like hold down the mouse and drag. So you can add glow effects to highlight the current hovered item, or maybe if it's a required field that you didn't somebody didn't fill in, you could put a glow effect and move control back to that component. Calendars, usual things that, a calendar selector. So all these are available. This is rotation, so we're going to rotate these. This is an edit box, so hello, FireMonkey, right? And also change the opacity, so now we can make those components disappear. So maybe you want to hide them from the user, and then, when the focus wants to get to it, you can bring it up either slowly or just have it appear. And it's, of course, fully editable regardless of the rotation angle, although it gets a little hard to rotate things. And these could even be moving. I could have, I told you it's hard for me to type upside down and sideways. So even if these were moving, you can still, Anders has all sorts of demos for things that are being animated as well. And again, those are effects. Here's tree view. So here's a list item that's got some text. So hello world. And it's got a button and a label and other things. So again, whatever you want, you can composite inside of components. Here's some other components that are available, and the T memo as well. Also, components inside of FireMonkey can be completely scaled. They're vector drawn. So this demo has a scroll bar which allows you to scale, I think, up to 200%. Notice it's got smooth vector drawn user interface controls. So we can set a T layout component, and there's also a T scaled layout component. So in a scaled layout, any of the components that you put inside of a T-scaled layout, if you align that layout to your client area and run it on a large screen machine or a smaller screen machine, it will automatically scale all the components and vector draw them. So it's a great way to not have to do the things we used to have to do in Windows to redraw all the controls based on resolutions and so on. That's just automatic as far as FireMonkey is concerned. And we can even this is the C++ version that didn't have that included. So we can take a 2D and let's go back here and bring up this one and run it inside of a 3D viewport as well. So here we just going to flip the whole scaled layout off into a three-dimensional space and bring it back. And the same thing here, even if it's scaled, right? And of course, we have full support for styling. And so on my machine in the users, public documents, Rad Studio, 9.0 styles, we've got lots of different styles that we can choose. So here's an Aqua style, there's a Macintosh style, so here's a Mac style, for example, and here's an iOS style that matches the platform. So you can use styles to choose the look and feel that you want for your application. Now I've got this application loaded, and I've compiled it for 32-bit Windows. In Delphi, we can also do 64-bit, but for Delphi and C++, I can also do Macintosh. So I'll enable the Macintosh version, and that's done by assigning a remote profile. And the remote profile needs to know what the name of my Macintosh machine is. That one's called Samwise Gamgee. What the port is, and if I had a password, key that in. So it's port 64211. Samwise Gamgee, we can specify other files. We can make sure the platform assistant is running by testing the connection. And then if we say run this application, it will now compile it for the Macintosh, and it will deploy it. So it says deploying, and then it will start up the application over the Macintosh. So here now is my Macintosh application. There's the controls demo. There's the switch to 3D, doing the scaled graphic drawn. These are edit boxes. Here's my opacity. Here's my rotation. So everything that you build with the same set of source code for C++ and Delphi runs on Windows and runs on Macintosh. All right, and that's also the power of the FireMonkey framework. Full animations, full effects, transformations. Again, all the user interface controls. You can have a menu that's associated with the window, or you can have the menu appear. So let's take a look at how that works. Let's go to our form. So here's the controls form. There is a menu bar, and it has an option that says use OS menu, and it was off in this example, which says put the menu inside of the application window on Windows, which is the norm, and put the app menu inside of the application window on Macintosh. But if you want to follow the platform style, this is another case where the FireMonkey platform will do the right things for you on Windows and Macintosh platforms, is I can check this box, use OS menu, set that to true versus false, and then let's run it again on the Macintosh. So it'll compile it, it'll deploy it to the Macintosh. And when it switches back over, notice now that in the Macintosh menu, all my menus are there. That's the normal style on the Macintosh, is to load, put the file and help and other menus on the Mac menu bar and not in the window. So use OS menu, true. It'll use the correct menu, of course, including quit. And if we compile this for Windows, for example, for Delphi 64-bit, and compile and run it, then, of course, on Windows, the menu is in the window itself, regardless of the setting of OS menu. So as we move on to other platforms, of course, I think iOS doesn't have a menu system, right? You just draw Anders inside of the user area to create your own, in a sense, menus or scrolling menus.
Yeah.
All right, so menu bar won't have any specific capability on iOS.
Let me start with the math visualization. This is actually available as an article on EDN and also on my blog at blogs.embarcadero.com/AO. You can download this application and play with it. So let's just run it and see what it does. So this application simply visualizes mathematical functions of two variables. So in this case, we have x and z. So here's the function sine of x squared plus z squared divided by the same argument here. We can move this around, spin it around in 3 dimensions. I'm also using one of these arc dials to rotate around the third axis here. I've got a track bar for zooming in and out. I can turn on and off the grids. I can pick various functions here. This is a function that does e to the power of sine x minus cosine of z. Here's the positive one. Here's a slightly more convoluted one. Actually, it turns out to be all the same in all quadrants here. And finally, one that's based on arctan 2 here as well. So, what does this actually do? So, if we expand the nodes here for a couple of different layouts that I have. First of all, this is a 3D application, so it's a 3D form as opposed to an HD form, which is just two-dimensional. So in order to get HD controls or a 2D interface, like my control panel here on the left side here, into a 3D application, I'm using a layer 3D. So this is a three-dimensional control that can then be shown as a two-dimensional layer by setting the projection to PJ screen, as opposed to the default, which is PJ camera. You can, of course, also put this layer on a plane that is projected in 3 dimensions, but this one is actually projected on the screen level, so it doesn't change if you move the camera around and change the rest of the 3-dimensional scene. And on this layer, just like a regular form, I have all my buttons and my checkboxes. I have a panel that contains the controls for zooming and rotating around the 3 axes here. I have my zoom track bar, I have my checkbox, etc. All of those are in here. So, for instance, on the arc dial, if we go to the click event, when I change it, all I change is the rotation angle, the Z part of the rotation angle for the layout 3D. The layout 3D is what all my 3D components are sitting on. So in this case, I have the 3 grids. You noticed I had, when I ran the application, I have the grids visible. If I spin around here with nothing in it, you can see just the grids, right? These are the ones that I can toggle with this button here. So going back to the code, simply rotating the entire layout, that will rotate all of the objects that are on that layout. So you rotate everything at once. In here, I also have the mesh. That's what's actually going to show the visualization of the mathematical formula. I have a text 3D item which displays the formula as text. Just copies the stuff from the buttons here, actually. So when we generate the mesh, if we double-click on one of the buttons, what happens here is that we set the text of the 3D item to the button 1.text and button 2.text, button 3.text, depending on which button we click on. And we'll call generate mesh. Generate mesh will go ahead and create the model or the mesh at runtime. So the first thing we do is tell it how many items we're going to have in the vertex buffer, the points, and also how many items we're going to have in the index buffer for setting up the mesh itself. So we compute that given the a couple of constants that we have right here. Max X and max Z, I've set those to 30, so it'll be between plus minus 30 is what we're iterating over. So this will turn out to be 2 times 30 times 2 times 30 divided by the step that we take. The step that we take by default here is 0.5. If I want to generate less points, for instance on an iPhone, an earlier iPhone where performance isn't as high as on the desktop machines, I can increase the step maybe to 2 and get less points. So then what we do is we iterate over X and Z, and we set up all the points. So we create the point. So here's my first point. I set the X and Z value. I also create 3 more points to generate essentially a square. Right. So the second corner will be then the first one plus a step. I'll have a third point, third corner, the lower right corner, if you will. I add the step to both X and Z. And then for the third point, the lower left corner, if you will be just the step added to the Z component instead of the X component. Excuse me. I calculate the function values for all of the points, all four of the points of that square, by simply calling f. F is my magical function here that, given different passed-in values, will compute values for different fixed functions. So you see the sine function right here. You see the other ones on the other lines here. So I have my sine minus cosine, I have my sine plus cosine, I have my arctan 2 right here. So if we go back here, so by now I've computed all the corners, all the 4 points of the corners of a square. Then I actually go in and set up the points in the mesh. So with the mesh data property, in the vertex buffer, I set up the 4 points. So here I have 0, 1, 2, and 3. Those are my points. I put those into the vertices property, vertices array of the vertex buffer of the mesh1.data property. Okay, let's get back to the colors in a little bit. And then, as some of you who have dealt with 3D in the past will know, everything is based on triangles. So a square, you can split it in half, and you end up with 2 triangles. So now we have 2 triangles. Each triangle is 3 points, so therefore 2 triangles is 6 points. So basically what we do here is the first triangle is points 1, 2, and 3, and from that follows that the second triangle are points 3, 0, and 1. So that sets up the wireframe itself as we're iterating through all of the squares in the XZ plane. The final thing that we do is we attach a material to the mesh, basically draping a blanket over it, if you will. And what I'm doing is I'm calculating a bitmap with different colors. I'm just going over a hue saturation table and creating a color strip, if you will, a rainbow strip. Not quite a rainbow, but close enough. The reason I have to call correct color here is that a few of the RGB, I forget which ones, are swapped on Windows versus Macintosh. So calling correct color will do the right thing based on platform at runtime, so it'll look the same. So I've created this color bitmap. Notice it's a line, and because it's a HSL color map, it's 360 degrees, so it's 360 wide in this case. And that is what the text chord array in the vertex buffer is all about. So we assign here a point in the bitmap corresponding to the actual function value, so that when, as you remember, when we ran it, we get colors depending on the Y value in this case. So down here we get the cooler colors, and then we get hotter and hotter as we get higher Y values. And that's pretty much all there is to this particular demo, I believe. the display grids here, all it does is turn on and off the grids. Pretty simple. Set it to is checked, so that'll be false if visible on the grids will be false if the checkbox isn't checked, and vice versa. Okay. Oh, sorry. Let's run that on the Mac as well. So now we're going to run it on the Mac, and I've already started my project Platform Assist daemon on the Mac. So it's just going to start it over here on the Mac, and I can run it. You notice it has the Macintosh Windows and kind of look and feel on it. Now I haven't styled this, so it looks kind of weird over here. We'll see a much better version of this later on in the afternoon here. I can pick the different functions, same as on the Windows. If you notice that we're actually getting slightly better look and feel as far as anti-aliasing, it's because the anti-aliasing is working much better on, this is a Macintosh. Did you talk about the setup that we have?
Just at the beginning with the setup, but I didn't talk about anti-aliasing as it relates to using VMs.
So I believe both of us have the latest MacBook Pros. We have 8 gigs of RAM. In my case, I have 4 gigs allocated to VMware Fusion. So that leaves about 4 gigs to the Macintosh. And of course, the Macintosh is the native platform here. So then anti-aliasing is working better on the native platform in this case. There may be a later version of VMware Fusion that does better anti-aliasing that I don't have on this particular machine. I have the 4 point something, I believe. But you'll see, it looks to me at least that on my Mac, they're a little smoother curves, and that is most likely because of the anti-aliasing logic in the VM. So of course I can rotate this around here as well. Look at it from the inside. Okay, let's close this one down. Let's take a look at another example, another 3D example, which is wave visualization. This demo pretty much follows from the other one. This does pretty much exactly the same thing. I generate a mathematical function as a 3D volume at runtime, but it changes with time. So in this case, it's a wave visualization. So as you can tell, when I turn on the first wave here, I can increase the amplitude. I can change the wavelength. I can change the velocity. Like this. And if I restart it from scratch here, to just get back to my defaults, I'll show you the what happens when you add another wave. So here we have a second wave over here. If we just show that, that's this wave, and again this one, first one. And if we add both of them in, then we get interference patterns in between them, and they of course get added on here. So if I add a third one and a fourth one, etc., we can get really interesting results. Of course, we can go crazy here and change all kinds of things and just add amplitude on different things. So just a simple example of how you can visualize physics, if you will, in FireMonkey. So if we take a look at, again, what that does, we have the same thing here. We have a layer 3D for the two-dimensional controls down here, and we have the layout 3D that just contains the mesh in this case. And when what we're doing here, this is also an article on EDN and posted on my blog as well. Again, that's blogs.embarcadero.com/AO. You can filter by FireMonkey category if you want to find it. We can post the links as well to the EDN articles a little bit later during the Q&A, so don't worry about that. So in this case, I just declare a helper record. I have a T-wave, whether or not it's enabled. I have the amplitude, I have the length, I have the position X and Y. I didn't talk about that in the UI. I can actually change the X and Y position of each wave and play around with that as well. And we have the velocity, or the speed. Then I have 4 predefined waves. The only difference to begin in the start values are the positions, X, Y. So we got negative 20 and negative 20. We got the positive 20, the negative 20 here. So all 4 corners of a square in this case in the plane. Then the generate wave function is pretty simple. In addition to what we had before, it takes the time as a parameter. So the wave function says that one wave is the amplitude times the sine of then 1 divided by the wavelength times the distance between where it is and where we're actually calculating the value. So in this case, we're subtracting x, the current x value, from the actual center of distribution for the wave, and same for the y, and we square those up and calculate the actual distance, and then we subtract the velocity multiplied by the time. And we're simulating time here. And we do that for all 4 waves, but only if they're enabled. And we keep adding them on. So we superimpose all the waves on top of each other. The rest of this is pretty much exactly the same. A little bit different layout here. I'm computing the value for 0.1, or 0.0 actually, in the square, 0.1 in the square, lower right corner, lower left corner, etc. We set up the vertices the same way by assigning the points. We set up the colors the same exact way as before, and we assign the triangles based on the fact that we split the square in half on the diagonal and compute 2 triangles. And that's it for this particular one. The rest is just setting the different values based on the changes of all these different UI elements. I probably could have used live bindings there as well to do all that. And why don't we go ahead and run this on the Mac as well. I'm going to run it on the Mac here.
I have a few more things to show as well.
Okay, cool.
In this basics, and then we'll get more advanced as we go into the afternoon.
Okay. So here's my first wave on the Mac. Change the amplitude again. I can superimpose a couple more waves on here. Calm this one down a little bit. And that's the wave simulation demo. Okay. Take a look at this one as well. This is I did a series of physics once, so this is a collision example. Of course, I did a pool table in this particular case. So if we run it to see what it does to begin with, here's the Windows version. So if we break the rack, then the balls will get hit and roll around. You notice it's a perfectly parallel scenario here, or symmetrical scenario, and that's because I've checked the perfect scenario here. Sometimes, in reality isn't perfect, right? So in a simulation, of course, you have to simulate the randomness of nature. So, of course, when you're talking about a pool table, the balls are not perfectly shaped. The table isn't perfectly flat. And maybe the collisions aren't perfect either. Maybe there's a little chalk on the balls. Maybe there's some stickiness going on, whatever. All of those things, in this case, I'm simulating by simply randomizing the mass of each individual ball, plus minus 5%, I believe, in this case. So if I uncheck the perfect scenario and then break it again, you'll notice that now it's no longer a symmetrical scenario. You notice also I have the use on idle here. It's based on a timer by default. If I turn on use idle as well, then I'm taking all the power of the machine, and then the simulation runs a lot faster. Right, you notice I get a slightly different scenario each time now, as opposed to when I ran the perfect simulation, where I get the same end state every single time. So let's run this on the Mac before we talk about it again, the actual source code here. So I'll run this on the Mac now. And here it is on the Macintosh. And again, you might notice that the balls look slightly better because of the better anti-aliasing on the native hardware. Let's see if I can get slightly above the iTunes thing there. There we go. Okay, so again, we have a perfect scenario. We hit break. And if we uncheck perfect scenario again, we get the randomized result. You'll notice the speed is a little bit different. I'm not using the float animations and things like that in here. This is not a multi-threaded application. It probably should be. The timer on Windows and Macintosh have different resolution, which is why I'm using the on idle. On idle, on the other hand, doesn't fire unless there's other events happening on the Macintosh side. So it actually fires only when my timer event's happening or when I'm moving stuff around. So you may have to set up a higher frequency timer or something like that that actually fires on idle more often in this particular case. So anyway, let's go take a look at the code. I notice David is answering a lot of questions. I'm sure we'll read a few of these and reiterate.
Yep.
But everybody should be getting, if you're looking at the Q&A window or the chat window, you should be seeing the answers coming through as well with the questions as well. So in this particular demo, I have the table is set up, of course, at design time. So I've got my camera, which is set on top of the table. In design view, it looks like you're looking at the table straight above it, but my camera is actually placed at an angle so you see the whole table from the player side, if you will, when you're supposed to be breaking. So the only thing I have in my layout 3D is my rectangle 3D, which is my table. It's just a green plane surface in space. and then I have, like before, a 2D layer, or a layer 3D, which is presenting my 2D or HD components, 2 buttons and the 2 checkboxes that I control the demo with. So the main part here is essentially that I have my T-ball. It is based on T-sphere, so that's a FireMonkey object. It's a 3-dimensional sphere which has things like width, height, and depth, as well as material, so we can put a texture on it. I'm adding a set radius to my T-ball, which will set all of those 3 values, the depth, height, and width, all in one. I assign a mass and a velocity to each ball for the physical simulation. I have a total of 16 balls, so there's 15 billiard balls plus a cue ball. So that's an array of T-ball. Then I have and by the way, this is also an article on EDN, and you can see how I did this. I have a helper function here that builds the texture of the ball. So depending on what number ball we have, we pick a color: yellow, blue, red, violet, orange, green, brown, or black. Black, of course, is the 8 ball, right? And then there's stripes and solids. So I generate that here as well. So this is if it's I add this if this is true, right? So I get my stripe in the middle on the stripes. Otherwise, they're solid colors. And then I add a circle with the number, and I put in the numbers. And that's all. So in the case of working with a canvas in FireMonkey, you need to call begin scene, and then you do all your canvas-related things, drawing, coloring, etc., etc., and then you call end scene, and that then you're done. My reset ball function will create the first of all, it'll free all the balls if they're already there, and then it'll create the new rack of balls from scratch. So here's the 15 balls that gets created right here. Depending on where we are, we set the X, Y, and Z coordinates. You'll notice that I have a lot of dummies. You notice those in the declaration of T-ball as well. I actually have 3 dummies, X, Y, and Z. This is so that I can rotate the balls independent of around the axis, independent of the other axis. If you notice in the demo, the balls are actually rolling in the direction of travel. So they're moving on the board, on the pool table, as well as rolling in order to get the bitmap to look like it's rolling, the sphere to look like it's actually rolling. So I'm basically parenting all these dummies inside of each other, and then the actual spherical object is inside of all these dummies. So when I actually do the simulation here in my do work, here's the actual physics. These are the this is the vector algebra for a collision. So I've got the velocity after collision for each of the 2 objects involved in a collision will be the initial velocity of before the collision, and then plus minus, depending on which ball we are, the mass of the other ball multiplied by c, which is the normal unit vector from ball 1 to ball A, dot product and the difference between the two vectors, then divide by both masses by the total mass, and then we multiplied that with 1 plus the coefficient of restitution, and finally multiplied by this normal vector again. That's all available online and in all kinds of different physics books, of course. So to begin the simulation, each single step, we reset the velocity changes, and then we calculate the new changes using all the different vector algebra helper functions inside of FireMonkey. So we take the distance between the two objects. We compute this normal. Like I said, the n, or normal. We create a use vector 3D normalize, and we subtract the two from each other. We compute the dot product to get this c here. And then finally, the velocity change now is the difference between using the calculation here. And once we're done calculating all the different velocity changes for all the collisions that may have happened, we update the velocities, we simulate friction so that we actually end at some point. We handle the boundary bounds against the rails of the table, the sides of the table. We update the positions of the balls, finally. And then the final thing we do here is actually do some magic to rotate the balls in the direction of travel. And that's where where the dummies come in, and we rotate again around the Z and X axis, and also a Y axis in this case. If the simulation comes to a halt, then we set done to true, and we're all done, and we enable the button for break again. So that's that particular demo. All right. Oh, and let me do one more before I turn it over to David again. So this is a multiform viewer. It was created by Stephen Ball in the UK. So here's an example of what you could do if you wanted to, as far as a 3D user interface for data entry. So this is a three-dimensional fish fact version based on what do we call that one again? Fireflow. Based on Fireflow. You may have seen
CoverFlow.
CoverFlow. I'm sorry, CoverFlow.
It's used it's used everywhere now. iTunes,
yep.
Netflix,
yep.
My Apple TV.
Exactly.
This whole flipping through books or movies or
so you
pictures.
have something in the foreground, and you've got the other rendered views that you can click through, and
those are all editable forms. Those are you could change the size of the fish, for example.
Yeah, absolutely, yes.
And notice the reflection effect at the bottom as well.
Yep, there's a reflection effect down here. These ones actually have a reflection as well.
So in this case, you're animating.
Kind of hard to see it.
You're animating the farm, right? You're flipping it to the left, turning it at 70 degrees, and shoving it off in the positive Z-axis to tuck it behind. Right?
Yeah. So in this case, when I click on something, the one in focus is animated out, and the whole rack is animated, and then of course the one you clicked on gets animated into focus. We can do the same thing with the track bar down here as well. All right, so let's switch it back to David for the. I think you had a few more you wanted to do.
Yeah, I was just answering a few more questions, but no problem. Okay, let me take control. Okay, here I am, and let's show my screen. Somebody was asking about physics engines, and I answered Box 2D and Newton Game Dynamics are two open source and available physics engines, but we don't ship any physics engines specifically in FireMonkey today.
Right, which is why you saw me simulating the physics in my application.
But in the Q&A log, you'll see, if you go check it, I'll give you the URLs to box2d.org and whatever it is, newtondynamics.org, or I forget what the link was. Just a few other quick examples. Andrew showed you the multi-form viewer. Andriano built an example which took CoverFlow and created something he called FireFlow, which does the same thing as forms, but it just does it with pictures. And we have that both for Windows and for Macintosh. So here are the demo pictures, for example. And it'll load all the pictures up. And the same idea is you can use the arrow keys, or you can click the mouse to go off. And again, if we look at the source code underneath, it's just doing several things. Let's go down. This is all the setup part. Let's skip through that and go to the transformation between the new and old. It basically is just doing a float animation and then delaying to wait before it starts the next one when it's animating over. So, this animate float of the cover picture, or it might be the picture that we're moving from. You can also call stop property animation and give it what you want to stop. So you can tell it when to stop and when to go. Just as in some of the other demos, we don't have a timeline designer currently for animations like you would see maybe in Flash animation. So you do it either in the object inspector by setting the animate of a property and set the duration time, or you can do it in code by saying animate float and then run a delay, because of course your method is going to run straight through. So if it sees a whole bunch of animate calls in a row, it's just going to start animating all the things, and maybe in some cases you want that. I'll show another example that's a very simple example that does animation and effects all at the same time. This one, you simply tell it animate a certain property and then do a delay before you do anything with that property again. And so FireMonkey will fire those commands off and just say, okay, I'm going to do the animation, I'm going to wait a certain amount of time. But other animations can take place if you so desire. And again, this also runs on Windows and Macintosh as well. In fact, all these demos run on Windows and Macintosh. And in the advanced section, we'll talk a little more on FireMonkey in action applied when we have to think about platform-specific operations. Because maybe on Windows you want to do certain things, and on Macintosh you want to do certain things. And of course, there's if-defs, and we've got a runtime structure that you can use to let yourself know what platform you're running on. So you can put an if-def, and Anders does this in when you see his mobile iOS applications, where you actually design the application on Windows, you can test parts of your iOS FireMonkey application on Windows, but other parts that are hooking to iOS hardware, like cameras and GPS and other things, those, of course, can only run on the hardware device, and in some cases on the simulator. But there, you'll want to put if-defs around. You'll see that in Anders' code as well. So we can put if-def, or we can use runtime dispatching on the different platforms. I just wanted to do one more simple example. Let's just put up an HD application. We'll put a button down. Now, in the IDE, if you've never seen our IDE before, maybe if you're coming from a different environment, you can, of course, grab all your components from down here, or you can use what is popping up is called IDE Insight. So the function 6 F6 key or command period brings up this dialog box, and you just start typing what it is you're looking for. So if I'm looking for a glow effect, for example, I can just start typing GLO, and it'll take care of things that are available in whether it's a command or it's a code template or it's a menu item or it's or a component. Those things will just pop up. So, for example, if you wanted to do a test case for unit test, or you want to do some of the project options, depending on where you are in the context. If I'm in source code, for example, it would show me code templates or methods that might match it. So here I've put a glow effect on a button, and notice the glow effect is enabled. I can also, again, disable it. You can see the glow effect at design time, and it sort of puts a glow, but it's not a highlighted glow. So you can see parts of that at design time. And again, on the glow effect, I can set a trigger. So is the mouse over true? And then let's just run this. And so now, oh, here, I disabled it, sorry. Where is it now? Enable, okay. So when I put the, I have the opposite trigger effect. So when it's glowing or not glowing. So the idea is I'm on it now, it's glowing. I'm off of it, it's not glowing. So this can call attention not only with the gradient fill and the glow to say that's something that you can do something with. You might have a disabled button. In the Windows world, we either would make a button and disabled, so you couldn't click on it, or you could make it invisible and then it wouldn't be there. And that's a little jarring, so we can use these kinds of effects to help guide us in addition. The other thing was the parenting. I wanted to do that with FireMonkey. So I have a label here. I'm going to put that label and an edit box, and put the edit box here, for example. And then if I parent all of this to the button, so let's put the edit box into the button and the label in the button, and then set their orientation. Let's put them like this. So now when I move the button around, right, everything comes with it because the parent now is the button. Let's turn off the glow effect just for a moment. So it's parented, and people have often asked, well, do we have frames or some way to composite components? And again, as I mentioned earlier, everything is composited, right? You can composite anything to anything, and the relationship stays the same. You can also inherit a form and create new forms. Just go File, New, go to Other, and inside of, depending on the project type, I'm in a C++ project here, I've got an inherited item, and I can create another form that's just like an existing form. And I can make that form, for example, this button, have a different text. But again, the parenting is still the same. So on this form, it's click, and this form, it's button. And if I wanted to revert back to what was in the inherited form, then I just right mouse click and say revert to inherited, and now it goes back to button and all the other properties, where they're located and so on. So you have lots of options. If you're used to doing things in Windows and you're coming to Macintosh and you want to get to Macintosh, all those things that you're used to in Windows with paintbrushes and canvases and so on, and parenting components and such, that's all available whether you're on Windows or you're on a Macintosh version. And here again, I'll just say add platform, Macintosh OS 10, compile this for Macintosh, and my PA server is running. And somebody was asking, there's been a couple questions about where do you get this platform assistant, this server, and it's, here comes my form, let's see where it is, there it is, C++, and again, all the parenting, the glow effect works and so on, all this works, right? And somebody asked, where is the PA server installs? It's in wherever you install Rad Studio or Delphi or C++ Builder exe2. Mine is in Program Files x86 because our IDE is still a 32-bit Windows IDE for now. Then you go to the 9.0 bin folder. Oh, sorry. I said in the bin folder. I apologize. It's in the 9.0, the root. 9.0 is the version of Rad Studio, and there's the PA server. So I'll fix that in the log. The executable is the Windows install for your remote Windows machines, and this zip file is the Macintosh version. Just copy that over to your Macintosh, unzip it, and install the package file that's the app bundle that's inside of there to install. And over on the Macintosh side, let's see, let's go to Finder. I've got so much stuff over here now. Let's go to my Macintosh. Let's go to the Intersimony, And here's it gets installed in Applications Embarcadero PA Server. And in my Scratch directory, which is, I think it's called My Mac, here are all my deployed applications. So, for example, that Fireflow application for the Macintosh is just there. My, what else did I build today? I built the controls demo, right? So the controls demo is just there, ready to be loaded, and the scaling works and so on. So, and there's the menu. Was the last time I did it, I said use OS menus. So all of your applications get deployed. And also when you want to go to the Macintosh from the IDE and you've got a Macintosh target, you may have some other files that you need to deploy. So under Projects Deployment, here in the Macintosh it says, okay, there's a few dylibs, like there's a exception handling unwinder dylib that has to go. I'm building with some runtime packages, so these dlibs for the runtime library has to go. You can also choose additional files. Maybe you're using a DLL or a dylib on Macintosh, and you want to send that over because it's needed for application. We'll see that a little bit later. There's also this button for feature files. So here's where if you need a driver, DB Express driver, to go over to Macintosh, for example, for Interbase or MySQL, then you can say, I want to deploy that MySQL, or you might be using our client data set, so we need the Midas library to go over. You can specify additional files that would be sent over when you do a run, a debug, or anything that would cause a deployment over. All right? And so it's under Project Deployment is there for you as well. All right. And let's throw that one away, and let me just go over, because there's two other parts. We talked a little about live bindings. Anders mentioned as well. What live bindings will let you do is every FireMonkey component, and now every VCL component, if you want to just run on Windows only, has a live bindings property. You'll see that, for example, if I have a image control, it can have a live bindings property down here. An edit box, for example. And so we use this binding mechanism different from what we used to do in the VCL days, where we had visual components and data-bound visual components. So we had a T-edit and a TDB edit. Now with live bindings, every user interface component can be bound to an object, to a data set, to a field of a database, to a column of a database. And so there's several binding components. One is called a bind scope DB. And what a bind scope DB does is it says, get the field data and the metadata for the table or columns or rows. Get that from a data source. So I'm getting data in this case from a data set, and it has a data source associated with it. The bind scope says take the data source, and then down here for my live bindings, for example, in the edit box, I'll just say get it from an edit control, and you can specify where the control comes from and where the data comes from and where the data is going to. And also, for example, for the grid, this is a string grid. I just have a live binding which says go and get everything from the bind scope. The bindings list is a list of the bindings, so we can right mouse click on it and see all of the bind expressions that are associated with this application. So for example, if I double click on this one, which is the edit, for that edit box, the first edit box versus the second edit box, it says get the value from the bind scope, the category column that's in the data set via the bind scope, and put that value, whatever it is, in the text property of the edit box. And for the second edit box, again, get the category from value and put it in the second edit box. For the image, we want to take the graphic column, which is a bitmap that's coming from a blob field of the client data set coming from a database, and send that into the bitmap property of the image component that's available. This one has an expression. You can also use simple operators and strings to create bind expressions. So in this case, we're going to take from the bind scope, we're going to take the record number, which is the row that we're on in the client data set, And we're going to concatenate strings, row colon space, to the toStr. There's a bunch of conversions that are part of the live binding system. So this is convert that record number to a string, and then concatenate a string, and then say of the total record count from the client data set, which comes from via the bind scope, and stick that in the labels text property. So label position is the name of the component, and its text property. You can also evaluate these things and see what they are. So if I want to evaluate the control, evaluate the source, it shows what the expression is going to come to. Since I'm on the first row, it'll say row 1 of 28. So you can sort of debug your expressions by using these components as well. And so the binding list has a list of all the live binding expressions. Let's just run this example. And let's activate the client data set. So again, the binding is taking the bitmap blob from the client data set for this triggerfish, and it's putting it in the image component. So I didn't have to write any code. I didn't have to do anything special. And the whole grid is bound to the client data set via the bind scope. So we've got all the fish in the rows and all of their columns and fields. And as I move, notice this expression is being reevaluated each time. So it knows it's on row 29, row 9 of the 28 rows in the client data set. Right, and we can go and edit and insert and do all the usual database operations using this is the bind scope's DB Navigator is available for us to use as well. So it's a tbind Navigator component that's part of FireMonkey. So that's a little example of using live bindings with FireMonkey. And one last example that shows that bindings can be very generic, where we can just synchronize a bunch of controls to each other. So here in this binding list of this example, we're just binding. We can even look at the description here. It says, well, there's 3 different expressions for this one. So let's look at this example. We've got take the value of the panel 1 track bar and put it into the text property of the edit box. So lots of bindings going on. In this example, let's just run it. So it says as I move this around, notice that wherever I change the track bar, I didn't have to write any code to say on change of a track bar, set the edit box and the label to that value. It's just the binding engine is firing off these bind expressions as required. And there's several ways to do that. We've got videos from Codebase 6 on how to trigger and design your live bindings. One is if they're managed bindings, then the binding expression manager knows how to manage its own relationships. If you're doing something in code, you can call a method on the live bindings engine called notify. If you call it with no parameters, then it'll reevaluate everything that needs to be reevaluated after you've done something in your code. Or you can say notify and the name of a component, and then it will just look for any changes in any of those components, and you can specify parameter as well. So check out the .notify method on the live binding system for you to say, I've changed something in my code, tell the binding expression, go and fire things. Otherwise, if the binding engine knows the relationship, it knows to reevaluate the right things. So here's another example where we're not only using the first track bar, but it's updating the value of the second track bar and this label as well. Here's some text. For example, as we enter to apply it, then the binding is from the edit box to the label, and so on. Here's a number, which is that drag, and when you're done, then it knows that it has to do an update. So inside of Embarcadero, Rad Studio 9.0, there's also the install for FireMonkey for iOS. That install package, you copy that over and run it, and it does a whole shell script of building up the compiler and building up the runtime libraries for use on iOS. So it's PA server. The exe is for Windows. You put that if you want to remote debug to a Windows machine, a remote Windows machine, a remote Windows server, whatever it might be. And the zip file contains the installer for PA server on the Macintosh. Is there other questions I didn't get to, or maybe we'll go through some of those questions?
I've answered them, but I wanted to go through a couple of them.
Right.
And just reiterate and read them off. So do VCL for Delphi and components for FireMonkey now have the native capability to display animated GIF images? And they don't do the animated part, but they do load the first frame. I just tried it in the FireMonkey application. So it doesn't animate them, but it does load the first frame of an animated GIF at this particular point in time. There are third-party components, of course, for that handle animated GIFs as well. Can I use the same license of my desktop Delphi to install on the virtual machine on a Mac? Yes, as long as you're the named user on all machines, and follow the typical as a book. You only use one at a time, and stuff like that. Platform Assistant comes with XE2. Yes, we talked about that. It's in the PA server folder under the installed image once you install it. Fusion versus Parallels as far as virtual machine. We've got customers and employees that are using both with success. Again, use the latest editions wherever possible for things like 3D and animate and anti-aliasing performance and those kind of things as well. VirtualBox, the same.
Yeah, there was some people have had some issues with VBox, with Citrix system where it doesn't support graphic acceleration, or there's some issues. So we haven't done it. I posted in there. We don't do anything special to work around problems or lack of support on Citrix or VBox. If there's an issue, you really need to go to those people.
This all falls on the virtualization vendors, and they're catching up fast, of course, with new developments. Even cloud vendors and co-location rack server vendors and stuff like that are sticking in GPUs and video cards where they used to be able to have where you essentially have a headless environment with just server blades, and then you run a virtual machine. Now they're actually sticking in video cards in there so that you have GPUs available as well in those racks. Can you create 64-bit Windows and Mac OS applications on a Win32 computer? Yes, everything is cross-compiled. The IDE is actually a 32-bit IDE, and it cross-compiles even to 64-bit. So
on Windows with Delphi for now.
On Windows. And
32-bit on Mac. 32-bit,
and it cross-compiles 32-bit Mac OS applications as well. So then you can use the PA server to deploy, run, and debug them on a remote 32-bit Windows, remote 32-bit Mac OS,
remote 64-bit,
or remote 64-bit Windows as well.
We happen to be running on Win64, so we can debug on the same machine that the IDE works. I don't have to do anything special. The debugger just switches to a 64-bit debugger under the covers and communicates from the 32-bit IDE to the 64-bit running process. Or,
of course, you can do Xcopy type deploy or email type deploy. You can just copy the executable anything else that's needed. For a Macintosh application, you just email or FTP or Xcopy the whole app bundle, and you should be set. Can we still type in the top of the tool palette? This was actually a question that came in when you were using the Code Insight, and yes, you can still filter in the tool palette.
And there's three ways, right? You can just
showing that right now.
You can just search through. You can type button, and it shows you all the things buttons, or you can hit ID Insight and show you all the things that are buttons as well. So you have all the ways.
Is there a way to generate DLLs from Delphi and then use them in the same Codebase to convert them to Mac OS? Yes,
absolutely.
Same way as an application. You add the platform that you want, and you hit build.
And you'll see that in the next section.
The package files that set up FreePascal, are they only used for iOS? Yes, they are. They are not needed for Mac OS. So if you're only doing Mac OS development and you don't want to do or don't need to do iOS development at this particular time, you do not need to install the FireMonkey iOS DMG file. Dylib and Mac OS, should they be installed on the system folder on the Mac, or can they be in the app folder as well? They can be in the app bundle as well.
Or you can userlib, wherever.
You can put them wherever. You can actually control where they end up using the deployment manager, if you want to show that real quick as well. For our DB Express drivers. Based on platform, we have the remote paths showing up as well. So they go into the app bundle, into the resources of the macOS, in the macOS file system. But you can deploy them to other places as well, assuming you have the rights to do so. That's the same case as on Windows, really. Can FireMonkey code be loaded into Xcode to be able to do things on the Mac that aren't available in FireMonkey? Yes. On the Mac.
We don't use Xcode.
No, we don't use
Mac.
Xcode for Macintosh. You can. There's no magic going on, so you can actually wrap some other framework that we're not wrapping, and you can use that. For an iOS application, we do use Xcode, so you can do things directly in Xcode as well if you wanted to.
But again, you have full access to the Macintosh operating system, just like you do for the Windows operating system.
Yep. And here's more of a roadmap question. Will we have a native OS X IDE at some point?
Not currently planned. There's a lot of code that's inside of the RID on Windows, and a lot of it is in the VCL, so we'd have to change over a bunch of this to use FireMonkey. It may be possible sometime in the future, but for now, it's a Windows ID.
Okay. So anything you want to add until we take a...
Well, I just put up this
break?
last example, which shows several things. It has two image components in the top. It's got a viewport in the middle, each of these in their own layout. And it's got an icon in the bottom. The icon's going to follow a path animation. This FireMonkey logo is going to flip off into three-dimensional space. And in 3D, so in 2D, X grows positive to the right, negative to the left from 0, 0, which is at the center, right? Y goes positive down and negative up from 0, 0, which is in the center. And the Z-axis is positive Z goes away from you or into the screen, and negative Z comes out of the screen towards you, all right, in the FireMonkey component system. And 0, 0 or 0, 0, 0 is the center of your form, of your application. So here we've got a couple things happening. We've got an image animation where it's doing a bitmap animation between two images. So over here in the structure window, we see a bitmap animation, and there's two bitmaps. The start and end value are there, and it's doing it at a 1.8 second duration. And then when I click start, it's going to animate these buttons. Animate these two images, animate the FireMonkey logo off into the Z-axis, and animate the path of this icon. And again, that's all done in code down here. So it says animate float position Y and the rotation angle, and then do a delay of the rotation angle and the position and for the time of the floating. And then for image 2, we want to animate that. So the two animations will happen. It'll delay before it does anything else. And then the icon's going to animate as well, and the FireMonkey logo is going to be animated. And again, each of these are inside of their own layer. And then the FireMonkey logo is inside of a viewport, since it's doing a 3D operation. And this example, I showed it running before. So the FireMonkey, it doesn't go behind anything because it's its own layer, so it sits on the top, but it is being sent into the Z, the positive Z direction. So it's going away from you only because its positive Z is being incremented as it moves. And then there's an iOS version we'll talk about later, which uses the exact same code with a little subtle difference that Andrews will talk about how the units are organized for FireMonkey on Windows and Mac. Or how they're named, versus how they're named for iOS, and that only has to do with what the free Pascal compiler supports in language compatibility or not. But you get the same full effect running on an iPhone or iPad with this application, with all the effects and the animations as well. So we're going to take a break for about, looks like about 15 minutes now. Let me bring back the agenda. And when we come back at 11:30-ish, so I want to give everybody about a 15, 20-minute break, but come back towards the bottom of the hour, we're going to spend a little more time specifically on looking at what it takes if you were going to build an application for Macintosh with a different language using Objective-C and the Xcode IDE, and what you would do to build a Visual C++, Visual MFC-based application, and how you can do it all with FireMonkey in a much simpler one set of code, and also then have it hook into infrastructure that you have, for example, web services, or call it from a .NET application. And Stephen Ball has a demo and a blog post that shows how to put FireMonkey forms in a DLL or a DLLs, and then call them from different types of applications. So we'll leave the agenda up, and we'll just leave no sound happening. But come back around about 11. Let's start at about 11:35. And we're going to continue on now with the FireMonkey Technical Workshop for building Macintosh applications and Windows applications. This section is looking at if you're a Visual Studio developer, Visual C++, or you're considering that you need to do Windows and Mac, but you're considering maybe to use Xcode on the Mac and write a different set of code, and then to have to write two sets of code. We want to show you how easy it is to work in our IDE, build for Windows Mac. We've already showed you Windows and Mac, but let's go take a look at some of the things that developers who are building using different code bases and different tools have to go through. And we'll do that for about 45 minutes or so to lead us up to the lunch break. We'll also show how you can build DLL or DLLs and call it from a .NET application, or call it from a different language application, and also how to support web services that are built with whatever those web services, those SOAP servers, are built with. In this case, it'll be a C# ASP.NET web service that a FireMonkey client can connect to, and then again works on Windows and Macintosh as well. All right. Let me switch to further on. I just wanted to leave the agenda slide up while we were at the break. All right, and let's go starting here. So if you're doing C++ using Visual C++ or C#, or using Xcode and Objective-C, or you're using command line tools to build your Windows and Macintosh applications with different code bases and different tool sets, we're encouraging you in this technical workshop, or beyond this if you're watching the replay, to check out using our IDE in FireMonkey. And we're going to look at a couple different things. First is how to build GUI application using the Macintosh, how to build a GUI application for Windows using Visual C++, and then how to do some interoperability as well. So on the Macintosh, I'll switch over to my Mac side, and I'll start up Xcode. And I'm not going to go through the whole step process of building a Cocoa application from scratch. I have a video where I showed doing that in a Windows Mac webinar that I did back in March, so you can always download the video of that if you want. Because there's many steps to doing it, and what I did in building this sample application is I followed Apple's tutorial. So there's on the Macintosh developer website, there's a building your first Macintosh application with Cocoa and Objective-C for the Macintosh. And it's this track mix, or beginning start of a track mix application. And this is the Xcode IDE. And you've got your project window over here, and you've got an object library down here with a bunch of visual components like buttons, different kinds of buttons, labels, text fields, things of that kind, things that you'll find in FireMonkey as well, radio buttons, groups, sliders, track bars, and you can set the horizontal and vertical orientation. So in this case, I've dragged three components from the object library in Xcode. We have a slider, we have an edit box, and we have a button. And up in this area, we have the property settings. There's a view. You've got the the attributes, they call them, for each. We call them properties in the object inspector. So you can specify things like alignment and the style and the label. So here's the title, mute the audio. Let's change it to mute audio, for example. And it does the right thing in the designer. And we can set the properties so it's a linear slider, and we can set its maximum and minimum values. Let's put this out of the way. So it goes from 0 to 11, because if you remember the movie This Is Spinal Tap, their amplifiers didn't just go from 0 to 10 like most amplifiers. They went from 0 to 11 because 11 was, of course, one more than all the other rock and roll bands that were out there. And you can set the current value as well. And then you have a button, and you stick the button down, and then you go through some operations to connect the different controls to parts of your application. And then you write some code to do synchronization between events that take place in the applications as well. So there's lots of different views up here. So, for example, and it uses a model view controller kind of architecture. So you can say what is a component like the slider connected to, and it's connected to a slider cell, and you can say what its outlet is. Maybe it's a formatter. For example, in this case, it's a sent action. When I move the slider, it's going to take the value from the slider and send it to an app delegate, and the app delegate is going to do something with it. For example, maybe update the edit box and so on. Same thing for the button. We want to have the button connected to the app delegate, and it'll do something like mute the audio, set it to 0. And we've got an edit box. If we take the float value from the edit box, we can take that value and make the slider change based on connecting it through an app delegate. If we look at the app delegate code, we've got a bunch of code here, and this is Objective-C code. I'm not going to try to teach you Objective-C. You can follow the tutorial. Just go to Apple's site or search in Google, My First Mac Application, and it'll show up on the tutorials on the Macintosh Apple developer site. So you have the notion of these actions, and so in this case, the action is going to take a float value from whoever the sender is, and then set the volume to the new value and update the user interface. And a lot of this gets generated for you. You can write code for it as well. For mute, if I click on the mute button, so its action, when I click on a mute button, I'm going to set the volume to 0 and call update the user interface, which will set the edit box to 0 and the slider all the way down as well. And then we've got an update user interface. If I change something in the volume of the track bar, then it will set the text field to that value. And we also have some initialization code that we can set for when the application starts. And otherwise, we've got a little variable, the current volume. So there's all these different settings that are generated by the interface builder inside of the Xcode environment, and then you write code to do the event handlers. And there's some supporting files where you create the main program gets created. Of course, it's application main, but there's also source code that you write specifically for the delegate and for the tracking that you would write and create classes for those. And then when you run it, you can specify how to build it, and so what you're building for. And it says, okay, let's see, enable developer mode on this Mac. Sure. That's right. Just like in our PA server, I need to log in to my Macintosh so the debugger can work. And then it will compile. And so it's compiling, and then the application will run, and we'll just see it in action, and then we'll switch to look at how we do it for Windows and Mac with one set of source code in FireMonkey. So build succeeded. It also takes the interface file, and so now I can move the slider up, I can go and set a value in the edit box, and when I change it, and I can mute to put everything back to 0. All right? So that was done in several steps, and you can follow. There's about a 50-page tutorial on how to build your starting application just by saying File, New, inside of Xcode, New Project, for example, and say you want to build a Cocoa project versus an iOS project or whatever you might have installed on your Macintosh. All right. And then if I switch back to my my Windows IDE, let's stop that application. I think it was still running in the debugger, so let's stop it. Okay. And let's go back to the Windows IDE. Okay. And let's close that FireMonkey animation, and let's go and open the track mix demo. So let's look at where did I put it? That's always a good question. Oh, here it is, down here. Okay. So in FireMonkey, we've got a track bar, we've got an edit box, and we put a button down. And we set the properties of the button. So I said, what, mute me. So let's go down to the text property of the button and say, mute me. And we can resize it and so on. We've got our track bar, and we set its orientation to vertical. So its orientation property is vertical or horizontal. So I say track bar vertical because I want to match the look of the My First Mac app. And I've got an edit box that has a value of 5 currently in it. So its text property is 5. The value of the track bar is current value is set to 5 as a starting point, and we've got the button. To create an event handler, we just double click on the button or look at on click. And on click, we just want to say edit one.text is going to get 0. If I can type properly. And also we want to set the track bar value equal to 0. Okay, so that's on our mute me. Otherwise, when we change the track bar, we're going to set, when we move the track bar, we're going to take the value of the track bar, in this case just in whole numbers rather than whole numbers in decimal places. I call the trunc function to truncate it, and convert that integer to a string and store it in the text. And if I change the edit box, then I'm going to take the value of the edit box and set that equal to, set the track bar to that value. So if I compile and run this application on Win32, then as I move the track bar up and down, as I mute it, and so on, and unmute it, all the events are firing. In this case, I didn't have to create any other classes or do anything else to following what Apple has as their first application. There's other ways to do things on the Macintosh side, depending on your expertise in Objective-C and Xcode. But here I wrote a couple lines of code, and laying out the components is just dragging and dropping them from the component palette and lining them up and using them. So much simpler, drag and drop, using the object inspector, building these simple event handlers. What is it, 4 lines of code? No other special operations. And then this application can also work on Macintosh. So we'll set the Macintosh platform and hit compile and run. And it will compile it and run it over on the Macintosh. So here's, it's downloading an update to Xcode at the same time in the background. And so now I've got my application, and here it is. And then mute, set it to 0, set it to 5, set it to 11, and it's all good. It's a Macintosh version of the application. So one of the great things then is one tool, one language, either Delphi C++, one way of programming, one set of components, one platform, but compiling and running on Windows and Macintosh. rather than having to use Windows to do it and Macintosh to do it. So that's the first part, comparing what you can do in the Rad Studio ID versus having to use something on Windows and then use Xcode on the Macintosh. Again, you can follow that whole tutorial on the Macintosh side to see all the steps involved. One set of code, all working. Now, if you're coming from Microsoft C++ world, let's load up Visual Studio 2010, and let's open up this solution, which is has a set of classes for customers, orders, and products that they're ordering. So inside of, for example, so here's the Visual Studio environment. Let's see what it's doing. It's coming up. So I've got a customer class, for example. Let's look at the header file. And it's got a customer class, and inside the customer class, it's got customer ID, name, address, all those things, and some methods for getting and setting customer information. And that's in the header file, and then in the source code, we're going to set the customer array, so the data for the customer items, and then we have the getters and setters are defined as well. And it's using the standard library for MFC from Microsoft to do a GUI application. We've got a customer dialog that is going to display the window as a dialog, so I can close it, and it's going to add strings to a list box of items, and these strings are going to come from the clicking on the button to load from the customer orders and products classes and put them in the list box of the dialog, and wait for me to scroll it, close it, do whatever. So let's run this example. So we'll just start it without debugging. So it'll compile the solution, and it's a dialog, so it's got the OK and cancel buttons, and I'll load the customer and order. So here in my MFC-based GUI application, let's go back to it, sorry. We've got customer Ben, David, Felix, Dimitri, the orders, and then the order items that are coming from the classes, calling the getters for those things. And when we're done, just hit close, and we're finished. So that's using MFC and Visual C++ to build a simple dialog GUI application that loads a bunch of data from a set of classes. Could have come from a database, and so on. And that's for Windows. Well, how can we get that to Macintosh? Well, let's go and make sure things are closed. Let's go down to our VC++. Let's load the customer and orders C++ builder project example. And we've got a button, and we've got a list box. And we've got the same source code file. So if I double click on the customer, this is the exact same source code that was used in the Visual C++ project, MFC project. The only thing I've done here is I've commented out the call to include the MFC standard libraries header file. We still use the same header file for the customer, which just is going to load up is going to declare the class for the customer class and declare the interfaces for the getters and setters. And the same thing for the orders. We've got that commented out, and in the products file we've got stdafx.h is commented out, but everything else is just straight C++ code. In our unit code, we've done a couple things. We had to include the header files for the customer order and product interfaces so we can get at those classes. We then, for the user interface on the button click, we're going to load up the customer. So we're going to get the customer information. We're going to create an iterator, and we're going to iterate through the customer list to load each customer and their orders and their products. So the body of this code is copied directly from the Visual C++ code with one change. So let's look. Here's the button event handler for clicking on the on button clicked event. I just grabbed everything in the body of this event handler from Visual C++, all the way from the comment down through the code, to the end. The only other thing I needed to do was in Visual C++, there's this, the string class is called CString, and in C++ Builder it's just called string. So I had to make that one change to drop the C from the front of the definition of a string. And that's used for loading these strings and then putting them in the dialog box. And then I have a helper function here called listBox_add_string, which again on MFC said listBox1 add string. In our world of listbox, it's listBox1 items add, and then the string, a C-style string that we're adding to the list box of items. So little subtle difference in the interface for listbox, but otherwise it's going to do the same thing. And this listbox add items, the other thing we added is over in the header file. We just had to create in the private section this listBox_add_string helper function as part of the form class, so that it was known inside of our event handler to add strings to the list box that's sitting on the form. All right. And let's go back to the source code. So taking the code that we had in Visual C++, exact same code, class declarations, removing the MFC part, changing this interface. Otherwise, we can use the same iterators, the same language for looping through the data stored in the customer order and product boxes. Pasting those in. Here's that helper function called listBox_add_string that takes this temporary string, and that's implemented up here to use the interface for a FireMonkey list box instead of an MFC list box. So one change of a line of code there, a change of a declaration here, and adding that interface. Otherwise, the rest of the code is exactly the same. And so if we compile and run this on Windows, we get the customers and orders, and it all works nice. And then if we change this to Macintosh and hit run or debug, then the same code is compiled for Macintosh, and we can switch back to our Mac desktop, and here it comes. And there's that same application running on Macintosh, now with, of course, a Macintosh look and feel. So FireMonkey will make it, by default, make the style look like a Windows style or look like a Macintosh style if you build for Macintosh. And, of course, we could style this whole user interface, again, by using the FireMonkey apply styles and style settings operations. But same source code, same event handler, coming from VC++ for MFC, a little bit of slight changes, and then using the FireMonkey framework to compile it for Windows and Macintosh. Okay, second thing to look at has to do with interoperability. Let's say you've got some code in VCL, you've got some code in C#, you've got some code in Prism, you've got some code, and you want to use some FireMonkey, and you don't have time to convert your whole project to FireMonkey. You can have FireMonkey code running in a DLL. So let's look at an example for that. So what we have here is we have a FireMonkey application. We have several different applications. The first one is a DLL. So it was file new, other C++ projects build a DLL. Right here, build a DLL, and then implement some code. So first there's a form, and underneath there's code that will go through and load up a set of images. It'll use a viewport 3D to have a 3D look and interface on a 2D form, and then it will iterate through calling file exists and iterate through a directory of images and display them, and then allow you to select an image from this list of images and display it. All right. So if we look at the main program by saying project view source, we've got a library. Use the library keyword for Delphi. Select image. Here's an ifdef for Mac OS versus not, and it has to do just with certain things that are specific to the Macintosh, and we can see more of that later. Otherwise, it's going to select a picture from a list of images that are out in a directory or folder on a Macintosh or on Windows. And when you select the picture, it's going to display it. And that's the main program and its name. Now, one thing to note, let's close this main program. If I change the target, when it's 32-bit or 64-bit Windows, 64-bit in Delphi, the extension is DLL. If I set the target for OS 10, Macintosh, it reminds me that that's the active project because it says I'm going to build lib select image.dylib. Dylib is the extension name for Macintosh for dynamic libraries. So here's the DLL. Then I've got several different projects. One is get the image from a FireMonkey a DLL from a Windows application. Here's a DLL, and this is from, one of these is from a VCL application as well. All right. So the other part in the project manager I wanted to highlight is that up here on in the toolbar for the project, if you're want all your projects as part of a whole group to be selected in the same way, then you can use this speed button under here for select the target, and it will change all the targets that are appropriate to that choice. So, for example, if it's some other project type that doesn't have a specific target, like, for example, if it's a C++ target, then it would just be OS X and Win32. Otherwise, we can set 64, and it'll set all the projects in our project group to be 64-bit as well. All right. Otherwise, we can say Win32. So let's just let's build the DLL. So we've got a DLL. That's great. Let's go and choose this example, which is a FireMonkey application, which allows us to, this is a VCL application, which allows us to select an image using that DLL. So let's go and run this one. So now I'm in a VCL 32-bit Windows application. I'm going to click this button, which is going to call the interface and use the FireMonkey form. So this is a FireMonkey form that was implemented in the DLL. And here we have pictures. So here's a reflection effect. Here's the selected picture appearing. And it does this little bounce effect to know that's the one I'm going to currently select. And it does the right thing. And again, this is and we can select one of them, and it just echoes back by returning the name and path of the file that's associated with the selected picture. So here's a VCL 32-bit application that is using a FireMonkey DLL to iterate through pictures in a subdirectory and give you the FireMonkey effects, and then select it and return the path to the VCL application so it can display it in its user interface. Here's a FireMonkey application that's going to use the DLL. So let's go and run a FireMonkey Windows application that uses the DLL. So we can again go and pick some pictures. And here we've got a I moved my IDE. But here we've got again a FireMonkey application now, which is using the DLL on Windows to select and return the path to that picture, whatever it was. Let me zoom this back up. So let's go and make sure we have a dylib version. So we'll go and do a build. Let's select this and do a build. So we'll create a dylib. Let's go down to this FireMonkey application that's calling the DLL, and let's change it to the Macintosh version. And we can go and look at the deployment options. And in here, notice that one of the files that I needed to add was that dylib, so the lib select image dylib as part of my deployment, because it needs to get over the Mac, or I could have copied it over manually, put it in user lib, or put it in my my Scratch directory where it'll be found by the PA server. In this case, to make sure I always have the latest version updated, I'm going to have it as part of my deployed packages. That gets sent over. The other one is some debug information, some icons, the file list for the app bundle, and the remote information. So we can go and run this application now. So let's say run it, and it compiles it. It's deploying it to the Macintosh. And now, let's see. What did I do? Oh, okay. All right. Let me start this one. Oh, I know. Hold on. Let me reset. Let's do. Yeah, I know. Okay. Let's do a build just to make sure that it's all okay. And let's go and also make sure this is built properly. So let's set everything to OS 32 and build this one. And then let's go and run this on Macintosh again. Sure. Okay. And then go to our application, which is running. Here's our FireMonkey Macintosh application. Click on Select Images. Find a place where there are images. And again, this is a dilib now. This is a dilib built with FireMonkey. Notice the reflection effects, and I can select the picture, whatever the picture is, select that picture, and it returns back the path, which is now a Macintosh path, right? So /users, /intersimony, demo, photos, picture 10. So one of the powers of FireMonkey and platform support is I can create DLLs and dilibs to build a reusable FireMonkey form and set of code. And then I can use that from a C++ application, from a Delphi application, on a Macintosh, one set of code, using a VCL application, a FireMonkey application. I can even call this from other languages that can load DLLs on Windows. So C#, you can load a DLL on the Windows. So let's go and so if you're using C# on Windows, then it knows how to load DLLs. Just as it knows how to load assemblies, which are DLLs basically in .NET land. So one of the great things about this is sharing code. So if you have a VCL application, if you've got a .NET application, or if you want to separate out certain parts of your application, you can build DLLs. And you can share them across all your other projects that know about DLLs. And again, the same code works on Macintosh because the DLL becomes a dilib when we have the platform chosen. And again, 32-bit Windows, 64-bit. Now, one thing to note, if you're a Windows person, you need to match up your 32-bit DLL with your 32-bit application and your 64-bit DLL with your 64-bit application, because DLLs run in the same process space. So if I set 64-bit Windows here, I need to also make sure and build for my DLL, build a 64-bit version of the DLL. Otherwise, it'll give you an error that it can't load the DLL if you try to call a 32-bit DLL from a 64-bit application. It'll say can't load the DLL because it can't find the 64-bit version. So let's run this 64-bit application. And again, now it's a 64-bit application, and it asks for pictures. And here's a 64-bit version of the DLL on Windows. All right. And when I'm done, it returns the value. And again, we could have a 64-bit version of VCL application that would call a 64-bit version of the DLL as well. All right. Okay, now let me switch to... So that was just how to call from a DLL or a dilib on Windows or on Macintosh, from a VCL application, from a FireMonkey application. And again, anything that can load that DLL can get the interface which is exported for calling that select image entry point, which is exported out of the DLL or dilib. You only have to know one thing. Now, why Windows and Mac? Macintosh is growing. More sales, more Macintosh is getting in the workplace. So, why not have one ID and one code base that you can deliver applications for your users or your customers that runs on Windows and Macintosh? And of course, if you want to get to iOS, Macintosh is the way to get there. Forrester now says, hey, he's encouraging customers that they do research for to support Apple hardware and the interface. in the workplace. If you're an ISV, you've got more customers to sell your products to by building Macintosh versions and Windows versions. And again, if you need to build applications for Windows and Mac, it will take you more time to have to rewrite the application twice on Windows and Mac, or money to hire a consultant to do the Macintosh development for you. You can do it all inside the Windows IDE in Rad Studio for Windows and Macintosh, 32-bit, 64-bit, and on Macintosh. And again, I did a webinar back in March, and it's available on demand, so you can just go to embt.co, WinMac 321. And I take you through building that Xcode and Cocoa application step by step. Or you can download the white paper from Apple and follow the steps as well. So again, you can I showed you how to take your Visual C++ code that you have for MFC and to use it on Windows and Mac with FireMonkey and C++ Builder. Next, what we're going to do is build a web service in ASP.NET using C#. And then we're going to use FireMonkey to talk through SOAP interface and through its interfaces to talk to that web service. And of course, that web service needs to run on Windows because it's an ASP.NET web service. But you can build a FireMonkey application, client application that runs on Windows and on Macintosh that calls that web service or any other web service that's out there using our web service component and our WSDL import wizard as well. So let's go to Visual Studio. Let's close this solution. And let's go back to the start page. And we've got a ASP.NET web service that's written in C#. Could be written in Embarcadero Prism. And it's got an interface method called Hello World. It's defined as a web method, which is simply going to say return the string Hello World from C# ASP.NET web service. And it defines the web service and the web service binding, and all of that gives us the WSDL for the application. Again, it's just a web service, and this is the code behind that's available for it. All right. So we'll run that without debugging, and so the web service will run, and it's got a little self-contained interface, localhost 4982892, and there's the web service. These give you the interfaces. By clicking on them, it shows you it's the SOAP 1.1 and SOAP 1.2 servers. We can build clients in FireMonkey that support SOAP 1.1 as well. And then you can actually test the operation to see if it actually does something. And it says, yep, by testing it, it's going to say hello world from a C++ service as a string. So that's the string we're going to get passed to us as part of the web service. But we can test it using this harness that's created as part of the service. And we can see the WSDL as well. So we can see the interface that's associated with it. All right. So that's running. Let's go back to the IDE and let's close this one. And we don't need to save any changes that I made. And I'm going to load my default layout. Okay. And then here, let's close. Oh, I see I'm in debug mode. Okay. Let's go to debug layout and default layout. Okay, great. And then I'm going to load up okay. This example, and let's look at the source code. Sorry, right here. So we've got a form which just has a button with a glow effect around it, and it's got a memo at the bottom. Let's go and view the object inspector. There it is. And let's go and dock it over here. And move this down, close it, and look at the properties. So inside of the memo, we're just going to place the string that comes back from the button. And in the button, all we're going to do is call the interface which is that web service SOAP hello world method. And we got that by saying new other web services. And we have this WSDL importer. So if I have the URL from my WSDL, or if I have a source file on my machine, I can pass that. And that will create this interface file, which is generated for you by the server. And in there, I specify the path to the WSDL, which is that localhost 498 port 49892 for the web service ASMX and the WSDL, and the default URL for the web service and its interface. And then this will use a component, a non-visual component called the HTTP RIO, or remote interface object, for SOAP. All this code is generated for us, so that all I have to do ultimately is call the interface that is registered. And the method is down here, it's called hello world. So the register method interface is hello world, and it's going to return some string, which is a result of some kind. All right. My program, all it needs to do is call the hello world method, and then and also it's going to use this thing called TOS version, which is a built-in structure that where I can echo the platform that I'm running on. And then it's going to do an animate, float, and delay of the string that comes back so we can see it flip around. Okay, fine. So my web service is running over here in the browser, and it's running on my server machine, or my Windows 64-bit operating system. And I'll run the client application. So it compiles and runs. This is 64-bit version, for example. If I click this button, it'll call the web service and get the result back and do that little flip operation. There's the flip operation. So it just says hello world from a C# ASP.NET web service, and this is coming from that TOS version structure, where there's many different fields inside of it that I can use, including the build number. But this just gives me the whole string. But we can also pull out parts of it if we have any version-dependent specifics that we might have to deal with on different platforms. We can get all of those through this TOS version structure in Delphi and C++. So since the web service support is a non-visual component, in fact, many or most of the non-visual components can be used inside of your FireMonkey applications. Unless they're Windows specific, then they would only work on Windows, or if they're Macintosh specific. Let me show you a quick look before we take our lunch break at an example of this OS version information in action. So here's a C++ version. In here, we just are going to dump out into the memo the OS name, the architecture. So here's it says if the architecture is TOS version AR Intel x86, I'm going to give it a nice little string here. If it's 60, if I compile for 64 or if I'm running on a 64-bit version of the operating system, then it'll tell me that. I can get the build number, the major and minor version numbers. I can get service pack numbers as well out of TOS version. And I can also see what platform I'm running on. Am I running on, so if TOS version platform is PF Windows, then I'll dump out that the platform is Windows, and I'll take the size of a pointer times 8. It'll give me the number of bits in a pointer. So if I'm running on compiled for a 32-bit version or a 64-bit version, it'll tell me that. So in C++, we just can decompose this structure, TOS version, and get at the different members of it to display our information. So if I compile this for Windows, it will tell me that it's Windows 7 service pack that I'm running on. On Windows 7, it's a 64-bit version of Windows, but I've compiled this application with our 32-bit C++ compiler by concatenating the strings Windows, and 8 times the size of a pointer. In 32-bit Windows, it's 4-byte pointer, so that gives us the number 32. If we compile this for Macintosh, compile and run it. So So it's compiling the C++ version with the Macintosh version of C++ compiler from us. Now it'll do the linking, and now it'll do the deploying. And then we'll switch over to our Macintosh and see. Okay, here's the Macintosh, and my application is up here running. And there's the OS version info. So it says I'm running 10.7.4. So that's Lion and the latest updates. And it's running on an Intel 64-bit chip, which is my Intel. Actually, Andrews, you said we have the same MacBook Pros. You have the Sandy Bridge, I think. You have the faster Intel processor than I have, the one the year before. The major and minor and the service pack. And again, it was compiled for 32-bit OS 10. That's the compiler we have right now for OS 10 with C++, and for Delphi, they're 32-bit compilers, but more to come on those. One other thing, I didn't do any special Macintosh specific, but I'll show you a last quick demo here to show how I can use a combination of this OS version information and to connect to databases. So this one is going to use our DB Express technology and our binding, live bindings technology to open up an Interbase database. So on Windows, I've got my Interbase 64-bit server running. On Macintosh, I've got our Interbase server running on Macintosh. So when I run this application on my Windows machine, I'm going to talk to my Windows Interbase server. When I run it on Macintosh, I'm going to talk to my Macintosh server. And if I look under the covers, there's one thing I need to do specific, is since I want to talk Windows to Windows and Mac to Mac, I use this TOS version platform structure and its member to see if it's Windows. Then the path to my database is going to be localhost C:\\. That's all that Windows-ism stuff. And then on Macintosh, if I'm on the Macintosh operating system, I'm going to set the database path to be the name of my computer. It's called Samwise Gamgee /. Of course, I could have an INI file or some text file or XML file on Windows and Macintosh that I would load that would have the right path to the databases as well. But it just shows you sometimes, and you'll see this in Anders' code, sometimes you'll want to put if-defs in your code for platform-specific things, or you can use this TOS version structure in C++ and Delphi on Windows and Macintosh for any platform-specific thing. So let's run this on Windows 64-bit. And here's the OS version information. And here I open the Interbase database, and I can go through the rows on Windows, talking to my Interbase server running on Windows. Let's go and run the Macintosh version and compile it, and it'll deploy it. And now I've got Interbase running on my server, running on my Macintosh as well. So when it deploys the application and then switches over, we can go over here, and here's the OS version information. And now I'm talking, in this case, if my server's running, which it is, now I'm talking to Interbase Macintosh from a Macintosh application. Oh, I didn't align the string grid to the client, remainder of the client area. So in that case, I use the TOS version platform value to help me talk to where my database is on Macintosh versus Windows, and the fact that the pathing, there's no volume letter on Macintosh, there's / versus \. So you can use TOS version on C++ and Delphi for Windows and for Macintosh, and use it to set up any platform-specific things that you might have to do or execute code. And of course, you can put if-defs in your C++ and your Delphi code as well. So we showed how to go to an ASP application. Again, it's a web service application written in C#. We ran it, and then we used the wizard to create the interface to that SOAP server. And then once we had that, we can build our FireMonkey application for Windows, for Macintosh, and then talk to the web service using the right URL to get to the machine where the web service is running. And the interface is there using SOAP. I could have that same client running on the Macintosh. It still is talking to wherever the web service is running on the server. And the last thing to do is that we can load up and call FireMonkey from .NET. And again, I showed that earlier. We had a FireMonkey DLL, the select interface. And all you need to do is is switch over here. Let's go back and close this solution. Maybe I didn't show. I was showing so many things. Let's go back to the start page. Here we've got C# calling a FireMonkey DLL. So I previously built that DLL for FireMonkey, which is the select image. So here's the DLL import call for the FireMonkey library loader. This is my C# code. And here's the path. I didn't build this one, but it's ... from where I installed it to get to the DLL for either 64-bit or 32-bit version of the DLLs. So here's the 32-bit version. Looks like we got both 32-bit there. Or the 64-bit is in there. Otherwise, it's going to call open dialog with set a filter, and it's going to say, get that open dialog, show the dialog, which is coming from my from this interface called select picture, which is in my DLL, and then I'm going to get the directory name and pass it that folder where my pictures are to select picture. Select picture is the interface coming from my FireMonkey DLL, and then once I select it, it's going to get the output of that function call and display it as the path to the picture that I chose. Right? So let's run this C# .NET application. So it says, here's my get file button, and it's asking, where's my pictures? Here's my FireMonkey DLL, and it's doing its thing with reflection and all the other options and the filters, which are BMPs, JPEGs. I've got some different ones there, and GIFs. And then we select one, and it returns back the path to this beautiful koala. So here again is a FireMonkey DLL being called from a C# .NET application. So you can have the best of all worlds, depending on if you've got some in-place infrastructure. Of course, moving to FireMonkey and doing Windows development and Macintosh development with one code base. But if you've got some projects that you can't move away with for a while, or you can't restart, you can use the tools that you're using on Windows. If you're a C# developer, a VC++ developer, a VCL developer, you can share all the code in FireMonkey, or you can switch over to using FireMonkey completely by reusing parts of your C++ code, reusing parts of your business logic, the database connections, your web services, and so on, and add those to your infrastructure. So, Anders, questions on this section before we take our lunchtime break?
Sure. You're referring to a previous webinar. Can you post that link?
Yes. The slide has the link as well, I believe. Let's... okay, I did... I clicked on something I didn't want to click. Oh, that's GDI Plus. Where was it? It was back here. I believe that's it. They didn't make it a link, so let me try that.
I'll type it in if you're looking.
Okay, and see. Why don't you see if that's the exact link to the on-demand? But that's because that's a short URL version, and it's not a clickable link in the slides. Although I can make it a clickable link, I guess, by going like this, right, and going like that, right? And now it's a clickable link, and I can go in.
I'm going to buy a new Macintosh. What are basic requirements, and what is needed to run Windows on it?
So here at work, people either have they might have a MacBook Pro, but people also use Mac Minis. So you can have your Windows ID connected over the network to a Mac Mini, which is very low price, and you can run and test your applications in that environment. It's very nice. The Mac Mini doesn't take much space. If you want to do everything on a Mac, Anders talked about the configurations that we use. MacBook Pro, 8 gigabytes of memory, and VMware Fusion for the Mac. I think that's $40 or $60 or Parallels. I forget how much that costs. And so, but you could have a Mac desktop. Could be an iMac. Doesn't matter. Anything that's a Macintosh or a Mac Mini. And what configuration it has depends on what your application needs to do when it's running on the Mac. So a Mac Mini with with 2 gigs of memory. Make sure you get a Mac Mini with a GPU, And usually Mac Minis, you have your choice of either the AMD chip or the NVIDIA chip. Same with the MacBook Pros. Ours MacBook Pros come with the NVIDIA graphics chip, and there's the HD. Intel HD graphics chip is on the motherboard as well.
Yeah. Some Mac Minis are actually, maybe all of them, I don't know. They try to be clever. If you have it set up as headless with no monitor attached, it'll actually disable the video card, including the GPU.
Right.
So in that case, you need either a monitor plugged into it or a null terminator for the VGA or video output. So
what did Marco have? He just has a cable that's at least 6 feet long, I think.
No,
did he have a terminator?
He had an alternator, yeah. For
okay, originally he had just a cable. He had a video cable that was at least 6 feet long, so it would, in a sense, terminate somewhere long enough.
Oh, I see.
I think it was 6 or 10 feet, but it was bizarre.
That might be enough to trick it, but anyway.
But a Mac Mini works, a Mac Desktop, iMac, MacBook Pro, MacBook Air. Eugene on the FireMonkey team uses MacBook Air for his testing.
All right. And with that, I think it's time for lunch.
Okay. So everyone, let me switch back to the agenda. We've got more FireMonkey to come. We're going to take a break till 1:30, so we can have lunch, and you can have lunch if you're on the West Coast, or a late lunch if you're in the Mountain or Central Time, or I guess it's sort of later afternoon on the East Coast. Take a break, get some work done, check your email, and we'll be back at 1:30. But we're here, so I'll be looking at the Q&A. I need to get a little bite to eat, and then we'll spend about an hour to an hour and a half, both of us, on some more FireMonkey technology, 3D technology, and of course mobile development for iOS using Delphi and Xcode Free Pascal. We'll talk all about that as well. All right, everyone, welcome back from your lunchtime or afternoon break, whatever it might be. This is David I back in the studio, and Anders Olsen's here as well. And we're going to continue now with the last part of our technical workshop today, which is more about FireMonkey in action, in particular a few more demos and how they're built with HD and 3D on Windows and Macintosh. And then Anders is going to show you a whole bunch during the remaining time on doing native mobile development, native code development for iOS, for iPad and iPhone. He's got lots of information about how to get your iPhone and iPad applications built, how to get them into the Apple App Store. Anders has got 2 applications running in the App Store, or installed in the App Store right now. He's got his clock and also his math visualization that you saw earlier running on Windows and Mac. He's got that running in iOS, and it's available in the App Store. I think he charged some money to start, just to prove that we could put an app in the App Store and collect money from it, but then he changed the price to free. And so you can download that. Just go to the Apple App Store and search for MathViz, V-I-Z, M-A-T-H-V-I-Z, and you'll see that. You can download it, the iOS app, to your iOS device, iPhone, iPad, iPod Touch. So we're going to continue. Let me switch. Let's see. I updated the slide just to put this little lunchtime break, but let me come over here and let's quickly scan past all that stuff that we did. Oh, sorry, I went a little too far. Okay, so I'm going to switch to my machine for a moment and show a couple more demos with FireMonkey and talk about how I built them, and then I'll switch it back to Anders for everything you can do with iOS. Let me change the presenter. Oh, and I also was answering questions during the lunchtime break, so you can see those in the Q&A. There was questions about, what if I have a C DLL? Can I have that on Windows and Mac? As long as you can compile that C library for Windows and Macintosh, you could do that, for example, with C++ Builder to create a DLL on Windows and a dylib on Mac. Then you can use that C DLL, just recompile it using our compiler. And I think, let's see, David was also asking, he's new to Delphi but not Pascal. What should he do? He's got a professional version. I sent a bunch of links. Marco Cantu has his handbooks for Delphi. He also has his Essential Delphi and Essential Pascal books. He's got an Amazon printed book site. You can also buy the ebook PDF versions of all of his books. Bob Swart has his books for Delphi on lulu.com for printed version, and he sells the ebook versions as well. And if you're just looking for a bunch of introductory articles on the language, delphibasics.co.uk is a site in the UK which has a whole bunch of articles that to teach you, loops and statements and data types and all of those things. Scott was asking, it says MathViz is still 99 cents. I thought you'd change the price to free. Okay. Anders? I'm trying to... Oh, okay. Anders says collecting the money for a party or something we'll have here. Or maybe we'll donate it to charity like we did the Haiti Clinton Bush Fund a couple years ago. Scott asked about what about playing like an MP3 file, and I said that the FireMonkey team is working on video and audio component support for cross-platform, but for now you can just call Windows APIs, and I posted the link to the Core Audio API documentation on Microsoft's MSDN site, and so you can call Windows API calls to open files, navigate to files, to play a file, for example. Then it's specific to Windows, and there's a Core Audio or whatever it's called on the Macintosh side as well that you can get the interfaces to and call from your FireMonkey Windows and Mac applications. So, and other questions were about what about serial port libraries? We don't have any serial port libraries ourselves, but there are many out there for USB. There's Turbo Async. Those are usually non-visual components that are sometimes platform-specific. And again, FireMonkey, you can use non-visual components, platform-specific components. You just mix and match, link them in, or have them as runtime packages and use them from your applications. In that case, you'll have to think about platform specifics. But if-defs are using that TOS version runtime data structure, you can use that as well. Somebody was asking, having a native compiler for Mac would be great for iOS development, and we're working on compilers for Delphi and C++ that'll specifically generate for iOS. It's only a temporary stopgap measure that we're repurposing the free Pascal compiler that helped us get to iOS for Delphi last fall for a lot of the FireMonkey library. But you can start using that today. All your FireMonkey code will simply move over when we deliver the compilers for you. And again, John Thomas did a blog post about what we're doing for C++, for 64-bit, for iOS, for Android. That's in his blog. If you go to the blogs.embarcadero.com and click on the JT or John Thomas link on the blog roll to the left, you'll see his article where he talks about the C++ roadmap going forward. And we also have a bunch of promotions going on to get you started today and get ready for the future as well. Let's see. People were asking about the replay. Yeah, we're recording everything here, actually on 2 different machines just to make sure. So we'll get all that, and the demo code and the slides, all of that will get put and linked off of the same page that you used to register. That'll switch over to being register now for this tech workshop to on demand. You'll also get an email. Even for those people who've left, you'll get a thank you email. Thank you for attending, and for the people that couldn't make it, sorry you couldn't make it, but it'll have links to all of that information, so it'll all be there for you as well. And I think that covers the highlights. The rest of it is in the Q&A log, so you can go and see the things I was posting in during the break. And yeah, MathViz is still okay. It's the Embarcadero party fund for now. Okay. All right. So with that, Anders, do you want to change presenter so that I don't do whatever I did earlier to your recording on this machine?
Yeah. I can probably do that. Let me see here.
All right, David I over here on microphone 2. Anders is going to make me a presenter. And now I'm a presenter, so it can show my screen. And there was that core. I think you're seeing that. And it's the core audio APIs link that I put in the Q&A log for that question. So let me switch back to my IDE, which is running over here on Windows, on my Windows VM. So one of the applications I built, which Anders showed other facets of in his math visualization and wave visualization examples, is I also have to think where I put it. What I wanted to do was take some data and map it to bind it to a map. You see this all the time in Google Maps or these kind of data visualizations where you have a map of the world or a map of a country, and then you map data to it, and it does something. It changes color, or it gets extruded into a 3D kind of view. So what I did was I took, let's see how I'm going to get to it. There's an open source product called Inkscape, and you can go to inkscape.org. And I installed the Windows version of Inkscape, and it will come up. And then I went to the internet and I downloaded an SVG file of the country of Brazil. So let's see, do I have that? Oh, now I have to figure out where I put it. Okay, desktop. Let's see. I think it's in this one. FireMonkey, Delphi, Brazil data. Oh, here it is. Here's the SVG file. So this is an SVG file for the states of the country of Brazil that I downloaded from the internet. And in Inkscape, there's an edit XML editor, which brings up this view. And there's all these different paths, and these paths are the path data in the SVG file for each of the states of Brazil. So if I select a path, it'll show me the bounded rectangle for the different states. So here's like, well, unfortunately, they name them numbers. So there's like Sao Paulo state. I think that's Sao Paulo. No, it's something else. But anyway, here's the path data. So it says move to. Now, an SVG 00 is the upper left-hand corner. So it basically, in these cryptic commands, it says move to a position and then start. And then there's either coordinates for lining or curving. So here's C for curve to. If it doesn't see a curve to a Bezier curve, then it just draws line segments from point to point to point. It's like drawing the pen, lifting the pen, drawing the pen, moving to another location. And that's how these SVG files and the parts of them were saved. So I took this path data string and I pasted it into a text blob in a database I called Brazil. It's an Interbase database. So for each state of the states of Brazil, I have a database. I have database rows. Let's go to my IDE. And so over in the Data Explorer Interbase, do I have Brazil over here? I don't, but I can get to it. I load up all the data. So let's go and look at the Brazil database. Here's the states query, for example, so for all the states. And the states have the state abbreviation, the full name of the state. There's a text blob, which is the path data, and an image, a bitmap of the state. So this path data, I simply pasted into the text blob all those move to, curve to, line to commands for each of the outlines of the states from the SVG file. I think Jason Southwell also has a whole component set for FireMonkey, or a component set that works with FireMonkey. One of them is an SVG component that will parse an SVG file and get you all the information as well. And then I built a FireMonkey HD application and stuck into it a viewport 3D. And I have a camera. So the camera lets me point at some aspect of the 3D scene that's in the viewport 3D, and I can move the camera around rather than having to move the objects around, right? So I can move the camera around, behind, and so on, and I'll use the mouse and the mouse wheel. Andrew showed you how he used that angle button and other components to create his own little control panel for rotating, zooming, and so on. And I have my database, which is an Interbase database, Brazil.ib. I have a query for the states. I also have another table in that database which has the population data. So it has the state abbreviation. That's the relationship between the states table and the population table. And there's census data that I got from the Brazilian government, which it's not every year, so it's not incremental. They skipped certain years. And then what the population of the state is for that census year. And then I have a data source for the population data and a bind scope component that'll bind that to any displays that I want to display. I have a track bar here that lets me move between the list of years that they're census data. And I have two checkboxes here, one for animate to have it run and for looping around the years in the census data. Oh, that's my camera. This is my camera, this line that's sort of there. I've got my camera, let's see where my camera is set. So I can go in the structure window and look at the different parts of the application. It's also a scaled layout, so it'll grow when I grow or I zoom the window. So all the components will scale properly. So the camera is out there. Let's see where its camera position. It's at -50, so it's 50 units out this way. And I've got a light, which is a T light you can put in. And the light has three choices, light types. You can have a point light, a directional light, or a spotlight that you can point at an object inside of your application. You can have multiple lights and turn them on and off or have them all be on. You can have multiple cameras, so you can enable a camera, disable the other camera, so you can, in a sense, lay out a scene like a TV show with a 3-camera shoot. So you camera 1, camera 2, camera 3, or you can move the camera around as well. You can also point a camera object at something. There's a camera target property that you can specify. So all this is available in FireMonkey for doing 3D operations. And so I have the light, which is in the layout. I have a layout here so that I can rotate what gets put in there. And then I have a default path 3D. So what path 3D is it's a 2D path, that path that I get from the SVG file. But it has a depth property, and so the depth property will let me take the population and extrude the state outlines over time based on the population, so we can watch the different states of Brazil from the beginning of census data all the way up to the recent census, which I think was either 2010 or 2011. Now, under the covers, I have code besides, and I can rotate using the mouse, and I can reset the camera to looking down at it. The code underneath this, here's my class, which is my form that inherits from T-form. There's the viewport, here's the camera, and so on. Here's some events, including the mouse down on the viewport, the mouse move that I use, and the mouse wheel that I use for rotating and zooming. Those event handlers, a button click. Here's the list of census years that I have. Notice it's not contiguous by year. The last one was 2010. I've got some colors so that I can map colors for each of the states so that you can differentiate the different states as they're being extruded. If the animated checkbox, if I check the animation checkbox, then I turn on a timer so that I can iterate through the different years. And so animate and continuously animate. And then also I have a loop checkbox. Here's my button click handler, which will open the states database. So I do that here. I say Brazil database open. I open up the states query so that I can get all the states. And then I go in and I save into an array the abbreviation, the name, and I save the path 3D component. In this case, I create instances of a tpath 3D for each state that I find in the state table. That way, in the future, I can use the same code if I have the countries of the world. I'll just create a path 3D for each country, and then I'll display them. So here, I create it, and then I parent it to the layout 3D that all the states drawings are going to appear. And I also take the path data as a string, and I store it in the Path3D's path data subproperty. So it's path property, data subproperty. So Path3D has a path property here, and it has a data property underneath that I post into there for each of the states. I also get the bounds, the rectangle bounds of the state drawing that you saw when I was in Inkscape. When I selected a path, it gave me the rectangle for it. And I set the X and Y position to position each of the states on the FireMonkey form, and I scale it to make it fit smaller. And then I set the height and width of that Path3D to be, again, the same scaling so it fits inside of my FireMonkey form. And I set the depth of it to 0, so all the states start flat without any population set. I set the emissive color of the material of the Path3D to the whatever state colors map for each state. And emissive means that the objects emit their own color. It's like they emit their own light. If you want ambient color, if I set ambient color, then wherever I put the light or lights and posted it, then I would get the ambient light. I could move the light around so it would like go shadow to bright to shadow, for example. In this case, I just wanted to have each of the states emit the light for their color. And then I also have on the shaft or side of the Path3D, I set its emissive color to be the same color as the material of the Path3D. And finally, I can set the fill mode to either be wireframe or FM solid. In this case, I want the shaft to have a wireframe on the side in the color of the state. And I do that for each state. I sit in the while loop. And then at the end, I set the population to the first year that there's population data and call this set state population depth, which will query for that year from the population table and set the depths of each of the states for the first year, which was, I think, 1870. So set population depth just says, open the query, go and find the state that matches this population index value for that year, and then set the depth to be the population divided by, I have a population scale factor, and I'm going to set the depth equal to that, so that'll be the height of it. And I'll set its position to be negative because I want the state's populations to grow out of the screen towards me rather than into. So we set the position of the path for each state to a negative z. And I divide it by 2 because the depth will grow from the 0 point in z, so it actually would stick out both sides. I want it only to come out of the screen in this case. So I divide by 2 to get the whole value of the z position. And then when I'm done, I call viewport repaint yourself, and I'm done. Here's this button click for resetting the camera position to a starting point, and this is the close button and the timer for animation, or if I change the trackbar to move through the years. And this is the code down here where I mouse down to rotate the collection of Path3Ds in my viewport. So I just set the rotation angle based on moving the mouse from the point that I clicked the mouse down and then start moving it. And on mouse wheel, I'm simply going to change the camera position as a vector based on the wheel data so I can zoom in and out of my states as well. So let's go and run this one on Windows first, so you can see it, and then we can run it on Macintosh as well. So here's open states. So here's the states of Brazil with their different colors, and notice now the Path3Ds for some states are a little bit higher because they had a higher population for 1872 when I started. If I move to the next year that their census data, notice they start growing. And if we keep going, you'll see eventually that Sao Paulo state, which is here, dwarfs population. Oh, it's this one. Sorry, this one dwarfs the population of everything. It's the biggest growing. Sao Paulo City and Sao Paulo State is the biggest growing. Now I'm using the mouse wheel to zoom in and out. And I can also just grab at a point and rotate around. and there's the wireframe on the shaft, but it matches the color. So we can use the mouse down. Anders again used a control panel. I just haven't added it to this application, and I can do an animation and have it loop around as well. So it just does it on its own. All right. So it's a combination of using database and data binding, using Path 3D component, which again is a 2D component with a depth, taking the SVG map data, so I didn't have to draw paths for each of the states, load those in a database, and use those to create the Path 3D coordinates and drawing. And then the rest of it is that little bit of code, right? And I have my rotate camera that brings it all back to the center. So we can, the back, I'm not doing anything with the back, so I didn't set the back color, so it's black, or null, sorry. So there's the back side of Brazil. And again, I was thinking about having the Brazilian flag be segmented by the different, in bitmaps for the different states. So if you turn on the back, you'd see the state flag of Brazil. But that's my data visualization using data coming from the database and using FireMonkey 3D, or in this case, a viewport inside of the 3D, and a scaled layout for the whole thing, so that when I grow and shrink it, I guess I didn't show that. So let's just, I zoomed it up. Okay, minimize, so it just grows nicely, right, in scaled land as well. And everything gets scaled appropriately. And on Macintosh, let's see, I forget if I had, let's try this on a Macintosh. I haven't tried this in a while since I rebuilt my machine, but it should still get the database from my machine. Let's see if I wrote the code with TOS version for the state. No, I didn't do that, I think, in the open database. Now, this is the Windows-specific version. But again, I could use that TOS version command to make sure that I set the path to the database appropriately to talk to the right database server, wherever that database server is. But it definitely runs on Windows 3264 and Macintosh as well. So that's, again, another look at using FireMonkey and the 3D aspects to do data visualization. And I want to show you just a couple quick more, and then I'll switch it over to Anders. Okay. A couple other examples. This is just a simple 3D viewer. Here we've got a viewport again. It's got a camera. Inside of the camera, in this case, he's got the light connected with the camera. So wherever the camera goes, the light goes with it. Inside the layer 3D, he's got a set of buttons down here, and he's got a stroke cube for displaying different shapes. And so each of these buttons will simply add an object. In this case, it'll add a cylinder. It'll create a sphere, and I guess the other ones, whatever it was, sphere, cylinder, cube, and cone. So we'll run this one on 64-bit Windows. And so there's the stroke cube to start. Now we're just going to delete whatever was there and create a new object 3D. And we can rotate them around by holding the mouse down and zooming in and out as well using the mouse wheel. Here's the cube. These are all FireMonkey 3D shapes. And he hasn't put any material on them, so he's just coloring them. You could, for example, take a bitmap of the Earth and wrap it as the material on a sphere or a cone. These are four all built-in 3D shapes in FireMonkey, and those work on Windows and Macintosh as well. So we can just run it here, compile it, and deploy it to the Macintosh. And then when it's running, let's go and get to it. And here it is. So here's that stroke cube. We could rotate that one. Let's delete that object and put a cylinder and a cube and a sphere and a cone. And again, all the zooming and all of that is available on the Macintosh. So same set of source code using a 3D viewer. One last example that I'll just run real quick that's part of this whole demo set that we'll make sure that you get your hands on through the landing page we have a component called tModel 3D. It's over here in the 3D. Let's see where it is. tModel 3D right here. tModel 3D supports Collada DAE files, Maya OBJ files, and Auto Autodesk Scene Edit files, ASC files. And so we've got a button here, we've got a dialog box, and the dialog box gives you the formats that are available, OBJ, ASC, and DAE. And here's the text that goes along with it for the filters of the dialog box. He's got a viewport inside of here and a grid that you can turn on and off, and this Model 3D component that's just sitting there. And then this Model 3D is going to get loaded and stored inside of once we get the open dialog, and we can scale it by dragging this little trackbar. The button just says clear the model, and then once we select the file from the dialog box, load the model data into the Model 3D component, and then scale it based on a scale factor that he has, and then re-display the model. And then we've got our mouse move, mouse wheel to rotate around. So let's go and run this example, compile and run it. The models are they're samples of FireMonkey models. So here's the AutoCAD ASE, ASCII scene edit file, Autodesk Collada DAE format, and the Wavefront OBJ file. Wavefront is created it, and Maya and other tools can create these OBJ files. So here, let's select the DAE file, and here's our little FireMonkey, and we can rotate it around. We can look through the grid, and we can go all the way around here on the FireMonkey guy and rotate him left and right, and zoom him, make him off in the distance, and have him come up really close as well. So there's the FireMonkey in action, waving, bowing, laughing, smiling. Right? There's the DAE format. Here's the ASE format. And we're looking at other formats, so it did it on us. That's the ASE file, and then they just all end up being the same thing. One way is if you have a different format we don't support, is you could use Google SketchUp Trial Edition to load a model and export it as another format, or use other tools to create the formats we support, which are right now ASC, DAE, and OBJ. We have a sample program that's in the Rad Studio demos in SourceForge that also opens up a 3ds from 3D Studio Max file. So we added this in, and we're looking at more to do in the future as well. So again, if you've got some drawn models that you want to add to your application, you can do that. And Anders already showed you how he uses the grid in his math visualization example as well. So just a couple examples that are demos that are available for using FireMonkey in the 3D world. And I think I've covered almost all the other ones. If we missed any examples, we'll make sure to get those to you. And with that, I will turn it over to Anders Olsen.
So let's knock out a couple of questions that are in here. There's just two of them, actually. One is a statement, actually. Add a TA animate float to the state's depth value, and it would look even more awesome in your demo.
Okay.
Sounds great. Is the Q&A saved with the recording so I can read when I play back a session?
So it's saved in the audio of the recordings. We also get a text file log that's after the fact, and we'll make sure to clean it up and get it as one of in the zip file with the slides and the demos. We'll put the Q&A text file if you want to be able to look at the answers that way versus just listen to them. But I always try to include the Q&A in the video and audio.
Right. So it'll at least be in the audio in the same order that we're presenting. So my turn. All right. So give me a few, and I'll make myself presenter.
Which one of you? There's two of you, Anders.
The other one.
The other Anders. Okay. And then I'll triage questions while Anders is showing you iOS development. And then we'll come back for Q&A, and we have some links to additional information as well.
This is just going to be demos, so I'm not going to kill you with PowerPoint slides. If you want to see slides and more iOS demos, then there were just the first round of invitations for my iOS webinar on the 6th of June, I believe. Just went out yesterday, or maybe it was this morning, I forget. Anyway, so on the screen you have my blog. I just wanted to do some housekeeping here first. So blogs.embarcadero.com/AO. You can find all the demos and things like that I've been posting over the last couple months in here. And I was trying to use the wrong mouse here because I've got two screens going. So here we go. There's an article on MathViz, and I'm playing sound on iOS. Actually, I haven't done anything with it yet, but in the comments here, there's stuff to do it that I'm going to definitely play with. So that's my blog. Here's a couple of articles that we were talking about earlier. Visualizing mathematical functions by generating custom meshes using FireMonkey. This is up on the EDN. You can go to EDN and search by my name, or you can just find the article 42007 here. If you want to take a look at it, it goes through the same stuff and talks much more in graphical detail about how I get the points and iterate and generating the color and all that part. The same article actually for C++. All the projects are in Code Central, so you can download them as well. This is translated just to C++. This one is for the physics, so this is the billiard table that we saw earlier. Talks about how it generates the images and how that demo works. Real quick, the same thing for visualizing wave interference. The C++ one I have here, there's a Delphi one as well. So we saw this one earlier. Very similar to the other one. Okay, the other ones we're actually going to take a look at right now. Yeah, I can probably put those links in the Q&A window as well. So, first of all, let's start off with a couple of demos. I'm not going to go through every single one here, but I created a bunch of components over the last couple months for iOS that deals with different things that aren't supported out of the box. So in this case, I have a subclass, for instance, the switch, so that we can add custom on-off labels and make them say yes, no, or something like that, the iPhone switch component. I have a pinch gesture recognizer, so you can recognize pinch and zoom gestures. I have a rotation gesture recognizer, so you can recognize rotation gestures when you use both hands and turn them in opposite directions on the screen to rotate something. The swipe gesture recognizer recognizes up, down, left, and right swipes. I have an accelerometer component that gives you X, Y, and Z acceleration. I have a little gauge component, not necessarily just for iOS, that shows up as a simple gauge that you can set min and max and current value on. I have a location component that gives you GPS, longitude, latitude, altitude, as well as compass direction. Reverse geocoder gives you an address, if possible, from a lat-long pair. So if you have a latitude, longitude from the GPS, you can turn that into an address. Just like if you've used Facebook for the iPhone or whatever, it uses the location, the GPS, to turn it into a location. So if I post on Facebook from my phone in Scotts Valley, it'll say near Scotts Valley. So they don't actually put the actual street address, which you can actually get if you get that down, but they just put the town or city or whatever they call it in the reverse geocoder component in the location based framework. Finally, I have a couple components for dealing with the icon badge. So if you've used the iPhone and you get notifications, for instance, emails or phone calls or whatever, the little numbers will show up on the icons. Those are called the icon badges, and you can set those to numbers. You can actually set those to custom text, but I have not. I haven't done that in this particular component. Email. You can send an email it simply fires off and opens up the mail component. It does not use the message UI framework or classes. Map opens the Google Maps application on the iPhone. URL opens a URL in Safari, and the phone component opens dials a phone number using the phone app on your iPhone. It does not do it from inside of the application. It actually opens this separate application, whether it be phone, Safari, Maps, or Mail. That's how these things work through shared application. Okay, so that is in Code Central. I'll figure out a way how to put these into the Q&A window a little bit later. So if you download these components, basically it's a package that you install, you open, and you install it. And then when you start a new project, you go to File, New, FireMonkey HD iOS form, for instance, here. Now we'll have, if we filter on iOS, which I named all these components, TiOS something, you'll see them all here. So if you drop down an icon badge component, for instance, there's no specific graphics to them or anything, but now you'll see the components. All it does is it has a number. The number will show up on it if it's 0 or higher. So by default it's set to -1, so it doesn't show up. So if you want a number that's actually going to display, you simply go and change the number property. Behind the scenes, of course, this component does a lot of if-defs and works with the framework, Objective-C framework on the back end. And if you want to take a look at that, how that actually works, go ahead and download the components and play around with them. Same thing with the email component. This one. So we specify a body. That's the body of the message, if you will. We specify a recipient. That would be aolson@embarcadero.com, for instance. And finally, we have a subject. And then there's a send method at runtime. So I have my iOS email 1. Oh, why is that not working? Oh, sorry. For each one of these, you have to. We have to go in and set the search path. You can probably do. I should probably do that through the package somehow. I haven't looked into how to do that. So anyway, this gives me a way to use IDE inside here. So search path. Am I just completely confused? Is that not what it's called? The search path. The search path. Why can't I find it in here? Is that it? No, that's not it. Because I'm not on. I used to be able to find it in here. Sorry, find it where? Project options? Oh, did I just... Oh, I know what's going on. I just created a form. I didn't actually create an application. That's what happened. Okay, sorry about that. So file, new, FireMonkey, HD iOS application. That's what I need. So let's do this email thing again. And then if I click on here... Yeah, okay, now I can do F6 and say search path. Sorry about that. So that's the one I want. And I need to specify my location here, which is on my desktop. my computer on the Z drive, which is actually the shared VM drive. It's under this one where I installed it, and right here. And I believe that should be it. We add that, we say OK, and we hit OK. And then it should work. Yep, iOS email 1. Now it knows what it is. So what I wanted to show here was just, send, simple method. That will just simply send the email. So you populate the properties either at design time or at runtime, and then you just hit call .send. What it'll do on the iPhone is actually open up the mail application, and then you have to actually send it from there. Confirm the sending of the email, because it won't send it without user input. Okay. Likewise, all of these components, the location-based one, for instance, this will have a couple of properties. By default, I have it set to update location and update heading. You can turn either one of these off if you want to. If you just want GPS coordinates, then you turn off the update heading, and you won't get compass heading updates if you don't need them, and vice versa. If you just want to build a compass, or you just use the heading, then you don't need to know the location. So you can save battery life that way. When you get events, on these events, they actually have components have events on update heading and on update location. And what we get here is heading data and location data. Location data is declared as latitude, longitude, altitude, speed, course, and then the accuracies, horizontal accuracy and vertical accuracy. Same thing for heading data. You get the magnetic heading, the true heading, and the heading accuracy. And I just copied and pasted these essentially from the framework. And here's the implementation if you're interested in it. It's fairly straightforward. It sets up a location delegate. And once we get a update to a location, we fire off the on update location on the event on the component, and likewise the on update heading if we get a did update heading event on the location manager. When I create it, I specifically make sure that you only have one of them, so you don't have multiples of these things floating around. I set the update to interval to 100 hertz. That could probably be dialed down depending on your application. And that's about it. As you can see, there's a bunch of if-defs in this particular in these components that deal with hardware. You also see the if-def FPC and the mode blocks and the mode switches here. Those are completely isolated from you if you just use the components, because in your actual application, none of this stuff shows up. So you can just use them very straightforward from there. And I'll show you actually some demos of these other components, specifically the swipe gestures and the pinch gestures. We'll see that in a minute. So let's close this down and take a look at a familiar demo. We looked at MathWiz earlier for Windows and Macintosh. So let's take a look at what I did with the for iOS. So the first thing that I did was there's about a seven-step process to convert a desktop project to an iOS project, and it involves I think I blogged about it or somebody posted on the news groups, but I'll make sure I blog about that too. So you can open up the project, the dproj file, and you can switch out the framework from being FMX to being FMI, and then you change the names of the DFM files to be LFM, and then you change the corresponding $R directive in the units, and there's a few more steps. But anyway, then you can open your desktop project in the mobile designer, if you will, as an iOS project. And that's essentially how I started. And then, of course, you have to take away the desktop isms and adapt to the user interface of a mobile device. So you'll use a lot more gestures on a mobile device than you do on a desktop, most likely, where you use a keyboard and a mouse. So if I run this, I can run this as a Win32 application, actually, and we can test out the UI. And if you've downloaded MathViz already, while it was free or while it was a paid app, either way, you've probably seen it before. So if I click on here, I get my function. I can change the rotation, rotate it around the different axes. I used an arc dial in here, probably not the best navigational controls, but this was kind of modeled after Google Maps in a desktop type browser. So it'll probably continue to evolve from here to find whatever the best solution is supposed to be, right? We can zoom using this. Maybe a trackbar isn't the way to zoom on a mobile device, but that's what I added before I added the zoom and pinch gestures. I can, here's my, it fades away too. Here's the example of the switch control. We turn off grids or make it opaque or not. We can have different functions. We can reset, we can put a custom function in. So if we change the custom function, maybe divide by 5 here, we can graph it. And this is actually powered by a T-expression parser, I believe it's called. It's a free component that's out there that you can use to parse custom math functions. So obviously this is not compiled, but it performs almost like compiled code. It's really, really fast. Very fast expression evaluator, and it was perfect for this little app. So let's try. Let's go ahead and actually run this on the iPad or the iPhone. Actually, let's run it on the iPhone first, and I'll show you why I decided to fade the controls. So if we rotate it this way, for instance. The reason I decided to fade away the controls after a while, of course, is because the controls take up a lot of the screen real estate. Maybe you should have it on subscreens. Maybe we should have options on other subscreens and things like that as well. Oh, this doesn't have. This is not the latest edition. But anyway, so even here, if you click on here, you can rotate, show the mathematical formula on the simulator. I don't have set up so I can show you an actual device today. For my June 6th, it'll be I'll use a camera and broadcast, or maybe even download one of these screencast software packages for iPhone and iPad. They use what's it called, AirPlay to send the screenshots over. So that's pretty cool. So here's a custom function. You can edit the custom function and hit the button over here, and I get my custom function rendered as well. All right, so now I can look at it. Okay, so let me. Yeah, there you go. This is actually the newest one, I think. Yeah, here we go. So here's the custom function. If I put something in, it'll be pre-populated. So here's my custom function. I can graph that. And let's see. I can't show any gestures because I can't simulate pinch and zoom. I don't have a way of having two mouse cursors to actually drag them apart. I forgot about that. Yeah, we can maybe at the end, maybe close to the end. We'll try that and show it on a real device. Okay. Oh, hold the Alt key for a pinch. That's interesting. Can I do that? Aha! Nice. Cool. Thank you. Oh, excellent. So here's the pinch and zoom gesture at work. Excellent. You learn something every day. Awesome. Very cool. Just the Alt key and then move the mouse. Click and move the mouse. Alt. The Alt key. Yeah, just the Alt key. And then click the mouse and drag it in and out. Zoom and pinch. That's very cool. Excellent. And I have not implemented the rotation gesture on this guy. So that's very cool. Thank you very much, Lee. I also had the wave simulation on here. We can rotate this one. Now, as you can tell, I have not adapted the UI for the wave simulation to actually fit on here, but it does work. This only went through the 5-minute process of moving it from a desktop application to a mobile application, and it just works. If I change it to an iPad instead, and I rotate it, it'll look it'll look as intended. If I actually rotate it, there we go. So here's close to what it's supposed to look like. And then again, checkboxes, sliders and stuff like that aren't necessarily what you're supposed to have in an iPad application. But so we changed we take some time to change it over to actual mobile controls, and it'll look great. As you can tell, it works just fine here. Okay, and then oh, interesting. The close button disappears when you rotate it. Actually, it's not there on the iPad. Okay, then we have to do it this way, I think. Yeah, you're right. I think sliders would be fine for the iPad, but not the iPhone. Yeah, this particular demo is not necessarily. It's even questionable if the MathViz is designed. It's more designed for the iPad than for the iPhone. So let's take. Some of you may have seen my Balls of Fire or our bouncing ball project as well in the past. Let's run that on the iPad. Okay, it's launching.
And you see those splash screens coming up. Those are PNG files that we generate. You, of course, can replace those with whatever splash screens and icons you want for your application in the program, in the list file list, and then those will get built into your iOS application.
Yep. So here's the we used this demo for the launch tour and launch webinars of Rad Studio XE2. So you've probably seen this demo before. And here, again, I just took the desktop project and turned it into an iPad project by simply going through that 7-step process or whatever. I can freeze the spheres in space. I can spin them around their axis, some kind of axis. I can make it go faster. And
those are just 3D spheres. What did you put, the chrysanthemum? Or
yes, that's good. Chrysanthemum.
Bitmap is the material.
This is the desert picture. It's mirror image so that it fits in nicely on the edges here. This
What
is
are those?
simply,
Are those 2 layers? Or
this is simply 5 planes that
T-plane,
have
okay.
images on them, and that's pretty much it. Then we can rotate the entire layout around X, Y, and Z. So we can spin the entire box, if you will, around in space. And, of course, then we can let the balls move around and bounce around in this box as well.
It's working harder.
Yep, it's working harder. And this works on device as well, which is pretty cool. So let's go to this guy. I have a fish project. It hasn't changed the name yet. This is consists of a DataSnap server and a DataSnap client. So here, as an article, I wrote an article about this as well. This is writing a DataSnap server and iOS client in 10 minutes flat. So our goal is to get a iPad or iPhone application that loads and displays a data set. This data set consists of simply a text title and a bitmap for each record. In this case, it's FishFact. In the actual demo we'll see running, I replaced the FishFact images with our own product images. So the idea here is to talk to an application server. So middle tier, being a DataSnap server. The DataSnap server knows all the business logic. It knows everything about the back-end database. And the client knows barely anything about those things. It only knows that it needs to talk to the DataSnap server, so it has a couple of methods to be able to do so. In this case, we can get the data set, we can get a particular record, we can download a specific graphic for a specific record. So we go through the steps here of creating a DataSnap REST application. We make it a standalone VCL application. We configure a port, pick a port. We tell it that we want a server module, and we want these sample methods so that we can easily figure out what we're supposed to be doing. And most important part, we need to add the mobile connectors. So in update 4 and later, we added the mobile DataSnap connector for FreePascal, so 4.2 and 5.0, so that we can talk to from the iPhone or the iPad to a DataSnap server running on Windows, whether it be written in Delphi or C++. Okay, we pick and choose a T-Data module, so we get one of those as well. We hook it up to a table, in this case BioLife. Just specify the path of BioLife. dbdemos GDB is installed on your machine, typically in this location. Users, public documents, Rad Studio, then 9 samples, data, and dbdemos GDB. We drop the IB connection down in a BioLife table. So very similar to how you create client-server applications today. And on the server method, the only thing that we do is declare a function, get dataset, and it returns a T dataset. And the get dataset simply opens BioLife and returns the table. So here we have, it's essentially 2 lines of code to return that dataset. And of course, in this case, we're returning the entire dataset. You wouldn't necessarily do that. You would return a result of a query that is returning, 10 to 50 records, whatever the case might be. You don't want to return too many records, because then you're increasing traffic. It takes a long time. You use a lot of memory on the device. You waste a lot of battery, and then you have to do local searching on the device anyway, which is just probably not the best use of the device. So then finally we write the client, the iOS client, and we get the proxy I noticed I missed that in this article, actually. I need to go in and add that, because these are all the files that come from the proxy. So the proxy, assuming you have one running, in this case I have one running in the Amazon cloud on 184.73.177.92, port 8087. You can actually type this in right now and go here and download my proxy for my particular project if you want to. So this is the way I usually do it, and then I save it, and this will actually contain all of these files. On the client side. So here, it contains all of these files. These guys, this is the what you get in that proxy download. You get a DBX connection, you get a callback, you get common stuff, you get JSON parsing stuff, JSON tools, you get separate classes for DBX value, the DataSnap admin, the callback channel manager, the proxy itself, which is what we're going to deal with, the REST connection. We're also going to use, typically you use a ds-rest connection.pass and ds-proxy.pass, and those are the units that you're going to be interacting with most of the time. So going back to my article here. On the client side, when I create a form, I go ahead and specify a host. This was during my testing. You can change this to my host ID, which was up here, the 184.73.177.92 and port 8087, if you want to play with this as well. We say that we want to use HTTP protocol. We create the proxy, which is basically creating an instance of the T-server methods, and we pass in the connection that we already created, the ds-rest connection, right here. And then it's just a matter of getting the data set. So we call the method of the proxy, get data set, and then we loop through it, just like a regular table. While not end of file, we do stuff. So in this case, we create a preview item. We set the height, the font of the tree view item. We set the text to the field name as string, the common name. We add that object into the tree view, the item. We create an image. We parent that to the preview item, and we align it to the right side of the control of the tree view item. We set the width of the image specifically to 128 pixels. And in this case, we have to do some magic trickery here. We have to get after the field name, the graphic, cast it as a tblob field, and use a helper function, extract bitmap into stream, and then finally load it from stream into the bitmap. And my helper function is right here. All it does is it creates two memory streams, and it saves the first one to the blob field. It saves the blob field information to the stream 1. We move 8 bytes into it because this the reason this has to happen is because of this is an old Paradox table, and in Paradox image blobs used to have a 8-byte stamp at the beginning, a signature that was basically the size and a 4-byte other type of header. So we fast forward 8 bytes from there and we save it to the other stream, and this is how we get around the fact that this image won't load otherwise. You won't have this problem if you use PNGs, JPEGs, GIFs, or anything else. Only if you're using old Paradox style images, like in the BioLife table. So maybe that was a bad example, but anyway. again, this is the final example here, final look and feel. So let's actually run this. So what we have here, this won't actually run on Windows. So I can't test the application on Win32 because the proxy will not run on Win32. It wasn't built that way. It wasn't intended to run that way. So first of all, let's go to this machine, 184.73.177.92. This is just to show that I have my server running. It's on port 8087. There's my fish server, and I have to deploy Midas.dll, and I have my products XML table. Instead of installing BioLife, I just created a products XML file that contains a couple of bitmaps and a couple of product names. Let's go ahead and do this. So netstat. Unless anybody connected, there should be almost nothing here, maybe 2 lines. Okay, there's the 2 lines. So now, when I go to my fish client here, it's going to immediately start downloading. Let me change the device orientation. It's going to launch. It's going to call get dataset, and it's going to load each image individually because I wanted to show the table as it's loading. So this is slightly modified from the article. So here we go. It's going to connect. It's going to load ER Studio, DB Power Studio, Rad PHP, Interbase, Delphi XE2, C++ Builder XE2, and Rad Studio XE2. I can scroll up and down in this thing, using, and then let's actually run this on the iPhone as well, just to see what it looks like. Okay, so here I run the fish client again, and it actually gives me some timing information at the top, and it's loading, and when it finishes go away, it just kind of fades away, the timing information there. Okay, so that's that part. Let's go back here and look and see if we got anything happening as far as netstat goes. Yep, and there you see, I'm not sure why it takes so long to run netstat on my EC2 instance, but anyway, here's a whole bunch of connections from my Macintosh host through the simulator. And let's see if we get to the end here. I should have 8 of them, I think. 7 blobs plus a dataset connection, and then maybe 1 for the iPhone and 1 for the iPad, so maybe 14 total, or 16. Not sure whether it's a micro instance, so maybe not performing really well right now, or some of you connected to it, and I don't know. Maybe everybody's downloading the proxy right now. I don't have an example of web services on iOS at this instance. I may have that on the 6th of June. We'll see what I'm able to get to. So the other thing I can't show you the iPhone right now, but what I'm going to do, I'm going to run FishFact on my iPhone. I mean, this client on my iPhone over 3G, and see if anything happens on the EC2 side. So I'm just going to run it once, and it's downloading. Okay, and hopefully now I have some mobile IPs on here when I run netstat again. Yep, there we go. The Mac ones disappeared, and there's my mobile IP addresses showing up. So just to show that the device and the server are disconnected. Somebody's asking about 10.207.7915. That's not going to work for you. That's internal to EC2. We have those internally here as well. 10 dot addresses. Those are typically internal addresses. So the external address is actually 184 up here in remote desktop connection, 184.73.177.92. Don't worry about this internal local address. This is the foreign address, my iPhone, and this was the Macintosh on the internal Wi-Fi network here at a 12 dot address. We'll close this guy down. So that's a really quick way of showing DataSnap connectivity to a DataSnap server that you create. Now you could have existing DataSnap servers as well, which is the case in my other example, the last one I'm going to pull off, which is my EDN. So I'm having difficulties getting this into the App Store, but I will get it into the App Store sooner or later. It has a few different things that you can do with this application. You can, of course, specify your username, your password, whether you want to persist it on the device. You can log on and get to more functionality. You can say that you forgot my password or forgot your password. If you have a username specified, this button will be basically calling the DataSnap server and telling members.embarcadero.com to send you your password to the account email on file for that account. So you can't snag anybody else's email address or a password that way. It actually goes to the account holder, of course. And then we have an account form, so just a little bit of last name, first name, email, title, and company. We can modify, edit this thing and submit changes. We have a contact form, whether you want to be contacted for EDN news or new products, services, and special offers. One idea was to turn on push notifications for this, which would be an interesting example. So get push notifications to your mobile device, iOS device, as we release EDN newsletters or release new products. Duplicate account information will show up in this. The info form, this is just an info dialog telling you, hey, this is this application. You can do this and this and this. The login form, what happened? That's the main form. The main form looks like this. This is the menu. One button is hidden by this little thing that's only going to be visible while it's making connections to the server. So you can get your registered products, your account information, your contact information, and your duplicate accounts. It'll tell you welcome, first name, last name, and you're logged in as the following EDN user ID. Finally, we have a product form that shows my registered products. So let me show you this first. How it actually runs. So when we run my EDN, it shows up with that screen. We put in a username and a password. I have specified that I wanted to save it, so you notice that since saving is on, it actually preloaded the username and password. And then I can log in. If I log in, it'll contact members.embarcadero.com through the DataSnap REST service. It says, welcome, Johnny Appleseed. That must be because I've specified that the last name is Appleseed and the first name is Johnny. Email is appletest@embt.com in this case. I've got a title and a company. I can change something like this and say Apple Test Company or whatever. Hit return, save the changes, and the next time I log in and pull the information down, it should have kept that change. So there we go. My my registered products. In this case, I actually have an Interbase license registered to the Apple Test account, just so that the app review team at Apple can see what's going on. My contact preferences are turned on, of course, because I want to know of all new products, all new services, and all special offers, as well as David Ice EDN newsletter. I want to get all those. I don't have any duplicate accounts. If I did, right now it's actually, over the last couple of years, it should pretty much be impossible to create duplicate accounts, but a lot of older customers may have duplicate accounts because we had multiple systems creating multiple accounts in the past, and they're keyed off the same email address. So basically what this does, it tells you all of the accounts for your email address, gives you all your accounts and tells you which one you're logged into. And then, of course, you can click on it and select the other one and log into that. So notice here that it gives you the EDN account number, the login name, Apple Test. That is the login name as opposed to the email address. If your login name and email address are the same, then it'll show you your email address here as well. And the info screen, of course, when you click on the info screen, you'll get, the information. So I'll go through that application much more in detail in blogs and EDN articles, and probably on the 6th as well in June. And I'll make the source available so that people can learn from it as well. And it is 7 minutes to 3, so let's do some Q&A here.
Did you talk about export to Xcode?
I did. You know what? I didn't. That's a good question.
So to show how you can get your iOS applications from our IDE over to Xcode, so you can compile them for iOS.
So typically, that's what you. I have. Let me show you one other thing first. So in this case, I have a VMware share, VMware shared folder. This is something I do from inside of VMware Fusion. Parallels probably has the same thing. You can share a Windows drive, or you can probably share different ways. You can go to a different file server that you have available as well. In this case, it's easy on the same machine to share a directory. So I put all the applications in this particular shared directory. It's my Z drive from my VMware Win7 instance. So I saved the project in this location. You'll see here if I do show an Explorer, you'll tell me where it is. So it's in that Z drive, right? Demos, iOS OS hardware demos, EDN iOS membership. This is where all those files are stored. Okay. Once I save the files and all my project files and everything, I can run DPR to Xcode. And in my case, I have just specified, I've put it in here, DPR to Xcode. I can go in and see what it actually does. So DPR to Xcode simply does fires up this program, DPR to Xcode. It's in your bin directory, DPR to Xcode.exe. It has the parameter that tells me where the framework, where the FireMonkey framework is installed, and then it gives the project name. Essentially the DPR name of the DPR file. Okay, so you run that once, and it creates the Xcode directory. And the Xcode directory is what you're actually going to be opening on the Macintosh side. So here we get the, where's my Xcode directory? It's probably at the top. Okay, don't worry about Win32. That is just simply because I ran it, tried to run it and compile it on Windows, and not realizing that the proxy does not work on Windows. It'll just pop up. Actually, we can run it here. It'll pop up in a exception telling me that the proxy does not work on Windows, like that. Fairly simple. So the UI does work, but of course, since I can't log in, I won't get to subsequent screens, so I can't really debug it that way. So, like I said, once I did DPR to Xcode, if I can get this one back, it will put a whole bunch of stuff in here. I've put more stuff in here as well, specifically the icons. I'll show you those in Xcode as well. So it creates all this stuff, and it refers back up to the files. And you will actually go, this is what you'll actually open on the Xcode side, this Xcode proj right here. It's actually a directory. One thing that I am using in this project is this custom switch that I have that has on and off labels on it. And this is true for all my components and all components for iOS that are not part of FireMonkey. You have to drop them into the Xcode folder, the source code. Otherwise, Xcode and FreePascal won't be able to compile them. So you won't be able. You'll get compile time errors, basically, that complain that it can't find your TiOS switch or whatever it is. So then on the Xcode side, what I'm actually doing here is, let's close this guy down, and here, my EDN is simply pointing to the Xcode folder under membership here for EDN iOS. I can pick up a separate directory this way as well, or go with one that I had before. So my EDN in this case opens up like this. By default, you'll have the Delphi icon here. I created my own EDN icons for my, so that's essentially what it looks like. Let me show you what it looks like for MathViz as well. So MathViz, so here I specified the app icons for regular and Retina, and for iPad as well. Okay, so let's go to Q&A now.
Okay. One channel's quick. What I'm doing for everybody is I'm taking a bunch of the links that we talked about today and that are in the Q&A log, and I'm putting them in a blog post on my blog so you can have them all there, and I'll add to them. I'll get these up right now, and I'll add to them with more from the chat log or the Q&A log as well. But I wanted to make sure and post this for everybody. All you have to do is look on my blog, which is blogs.embarcadero.com/David in about 2 minutes.
Mm-hmm. So there's a question here. Is there an easy way to chart data that's in a database? I want to create a chart for a few data points. You can get T-chart. It's not, I don't believe it's not in Rad Studio for iOS. But you can get
T-chart Lite's available for Windows and Mac, and then you can go to Steema software, yep. STEEMA software,
and get the iOS version as well, and it does work. Source code, I'll make sure I post that, and at least before the 6th of June, before that webinar for my EDN.
I put into the Q&A log the link to your blog, the iOS category link. So if you click on that link in the Q&A log, that'll show all of Andrew's iOS tagged blog posts.
I was having trouble installing FireMonkey with Xcode 4.3.2. Is this version of Xcode supported? Yes, it is. There's a couple of tips and tricks there. You can look in the, I think it's the first lesson of David I's
Getting Started series.
It's all documented. It's a 50, 60-page document or something like that. Specifically, there's some issues there. You may have had 4.2.1. You may have had Snow Leopard in the past. Maybe you upgraded to Lion. Maybe you just downloaded 4.3.2 on Lion. And the first thing that will bite you is that 4.3.2 no longer has the command line tools installed by default. You have to go to the download section in Xcode and install the command line tools specifically. You may also have to install 4.2.1 on top. If you already had 4.2.1 and you install 4.3.2 and you decided to take away 4.2.1, what happens is that it actually kills the entire developer directory, and that includes our FreePascal installation and our FMI installation, FireMonkey for iOS. So if you just have 4.3.2 right now, what you would probably do is download the command line tools, download and also install 4.2.1. Then you would be able to install FreePascal 2.6.0 and FireMonkey from our FireMonkey iOS DMG file. Do you know the latest version of Xcode works with? Yes, with hotfix 1. Yes, yeah, same thing. That is the same answer as duplicate, differently asked. But yes. And with that, I don't see any more questions at this point.
Yeah, I posted some of the links, and I'll get more into this blog post today, but it's there, and I'm going to put this in the Q&A log. I'll put it on the... Oh, if I can paste properly. No, that's not it. Let's see. Hold on. I'll get it. So I'll copy it, and I'll paste it over here in the chat log. In the Q&A log, if I can ever paste properly. So that's the link. I put it on, I forget which one of them, but maybe it was Mike's post. I'm not sure. But if you just go to blogs.embarcadero.com/DavidI, I put links, and I'll go through the QA log and update it. There are some additional links I put in the Q&A log that I'll add to the blog post. But it has links to links that were mentioned in the slides, upcoming webinars, including an Embarcadero Prism Windows 8 Metro webinar on the 29th. Dan Whalen, who's a Microsoft C++ MVP, is doing a webinar on the 30th to help Windows C++ developers who need to get to Mac. And Andrew's June 6th webinar, creating mobile iOS apps using Delphi XE2 and FireMonkey. Those links are there, plus the links to the C++ roadmap, FireMonkey information, the Quick Start Guide, my Getting Started series, and also there's a great FireMonkey architecture poster, class diagram poster that you can download the PDF and print out on a big printer and stick it up on the wall in your office or your workspace. But there's other ones that I need to add in addition. Anders, why don't you give me control so I can finish just the summary slides real quick.
Okay, there's one more question.
Okay.
Mike says he missed the Xcode version. So you can use 4.3.2, that's the latest, or you can use 4.2.1. If you're targeting iOS 5, you do need to have 4.3.2 because it comes with iOS 5.1.x or whatever. And you also need Lion in that case. So it depends if you're Snow Leopard or Lion, really. Rich text component coming soon. That is definitely on the roadmap. So okay. I will give you control.
Give me control, and I'll go to my. Let's see. It'll probably pop up. Show my screen. And everybody should see it. So there's my blog post, again, with links. I just need to, I'll add more links to it, but it just says it's titled Links Used in Today's Mac Development for Windows Developers Workshop, and it's just the top post, most recent post on my blog. Just to summarize, Rad Studio XE2, fast native code applications for Windows, Mac, web, and mobile. Speed up your development process with the visual design, component-based development, drag and drop, HD and 3D. Build applications that connect to databases, connect to web services, connect to cloud infrastructures, connect to DataSnap servers. And it can work side by side with the work some of you are maybe doing and using Visual Studio. We have a couple special offers happening right now for C++ developers. You can buy XE2 and maintenance bundle. You'll get it gets you your ticket to the future of C++ and save some money in the same effort. Andrew's got a link for that off of his blog, and it's off our website. Also, if you buy Delphi or C++ XE2, you can get Rad Studio, which includes everything Prism, PHP, for $99 more. That's just go to embarcadero.com/rad offer. There's my Getting Started series. Lesson 4 is tomorrow at 10 o'clock for Delphi developers, 11 for C++. Each course, each Thursday comes with a course book, and then the video replays appear and the course book appear online, hopefully by the following Tuesday. That's been what I've been hitting so far. Tomorrow is about programming languages, very high level, just as it relates to using FireMonkey and doing platform independent development. This is the upcoming webinars I mentioned again. The 29th is Windows 8 Metro application development with Prism 2.5. May 30th, a Microsoft MVP. Dan Whalen's going to talk about what he sees when he's developing in C++ and needs to go not only support Windows but also Macintosh. And then Anders' webinar. And all these links are off of our events menu off of the Embarcadero homepage as well, and those are linked off my blog post. Roadmap article by John Thomas about the future and where we're going for C++ with our new compiler that's C++ 2011 compatible, as well as targeting iOS, Android, all that with native code. A lot of FireMonkey info off this main link, FireMonkey-info on embt.co is the short URL. The quick start, which is on our which is in our doc wiki, get you started, and my course is following that orientation, but I'm adding lots of materials. And here's the PDF for that FireMonkey big poster. That's all in our on the blog post. And here's a whole bunch of other links to just the Delphi community, the C++ community, just put CPP on it. Codebase 6, we have a lot of video replays, lots of videos everywhere about all sorts of things in doing Windows and Mac development, FireMonkey development. We're on Facebook, Twitter, and LinkedIn as well. And then there's lots of blog posts about technologies and where we're going and how to use and do Windows and Macintosh development with all the different bloggers that are here as employees in Embarcadero. So with that, I think we've covered a lot of the Q&A. This is just our email addresses if there's anything we didn't get to. A. Olson at Embarcadero.com, David I. at Embarcadero.com, the landing pages for our products. And if there's any other things that show up in the Q&A log in the next few minutes, we'll handle those and make sure we get all that information back to you. Thanks, everyone, for being a part of this online technical workshop. And we'll see you again on upcoming events.
All right. Thank you.